Okay, good morning, good afternoon, good evening. Welcome. Sorry for the late start. I had to get prints going and then that interrupted the flow, so I had to round up the critters. So, hey Rick, hey Martin, hi Bill, hi Joey, hey Malfrey and Steve. What else do we have here? Tuxedo and B. McNichol, Aquas. What else do we have? I saw a few more. What do we got here? Nice and Fegley, the Ranch Kid and Lars. Hey Thunder Keys. Hey Rod. How are folks? Hi Eric. Oh, we are back on the Blue Bear build. So last time we had a great, I think we had a good stream learning some of the things about frame assembly and finding little bits, little tiny things that can impact how a frame goes together and sits. So I think that was a good thing. There's 1 year old, 1 year and 2 days. Oscar and Felix turned 1 on the 12th. Tomorrow we will have a special treat time. We have some treats with some catnip in it. So yeah, I saw you wearing it the other day, Bob, and I figured I like this graphic. Eat, sleep, oh geez. Eat, sleep, print, repeat. Hi James. So anyway, I was printing TPU feet for this. I had forgotten to do, so it was something to do. Hey, Thunder Keys. I have been working on a couple of things so we can do quick updates this morning. For anybody who is watching the mill assembly with Bill here and Bob on chat duty, the mount for the auto feed for the X is less than ideal. So I spent some time fixing it, modeling a alternate mount. So this is what I came up with, and this mounts on the end of the table using 2 existing screw holes and then located holes for the mount. Where are those pieces? For the mount for the device. Where is it? Oh, that's weird. I got things all over the place. Anyway, piece goes here. There's a bearing here. Spent this is 4th iteration, just tweaking hole locations because there's no CAD for this. I just kind of took my calipers and figured it out. Hey Morton, hi Raj. So, and it turned out pretty good. I'm pretty happy with it. So there's 2 threaded holes here, countersunk holes here, and then a counter bore for the bearing. So I decided to order these from Send Cut Send. My very first Send Cut Send order. So my idea here was I would have them laser cut at a 1/2 inch steel, laser cut the perimeter, because that is the most difficult part, even on this machine, for me to do. And then I would do all the counter bores and finish machining. Hey buddy. So Felix is here. Felix is here because he found in that little trash the ooze from purging, the purge from changing filament. And one of his favorite things lately is to find those and play with those. And he thinks it's still in there, but I actually took it out and threw it away. So he thinks that he can find, oh, yep. He thinks he can find a bit he can play with. This is not blued still. I believe this is just probably hot rolled steel, and this is just from the laser process. Now I did have them tap these holes because the laser process can harden the edge, and they're without doing more like drilling out and stuff. I was afraid the risk of breaking a tap in one of these was higher than the cost they charge to tap those there. So anyway, this is going to get cleaned up, and a boring operation on here, and then a counter bore bit for the screws, and hopefully that'll get me further along to using this thing. It is very dark. You're absolutely right, Tuxedo. It is very dark. But yeah, it's really neat that the thing that I modeled in CAD is now a nearly 2-pound thing, and so okay, let me put this out of the way. The other thing I've been working on, for those that are going to Midwest Rep Festival, I redesigned my maker chip. So I realized that my logo all on its own would make a good maker chip. So I did all the modeling for that and printed it on the MMU3. So the little black borders where they should be. I did, for the most part, I minimized tool changes by doing this silver around the middle. There's several layers in the middle of this that are no tool changes. So, and the rest of these are all of the same heights, same depths or whatever. Hi Ella, thanks for being a member for 27 months. Hi, James. So, yeah, I'm pretty proud of that, and it's turning out awesome. For the very first time ever, I enabled ironing on a print just for fun. All of these maker chips, because of the small areas on the top surfaces, end up with just a little bumpy. The trick is to grab two of them face to face and rub them together. I figured I'd see how ironing does, and it completely eliminates that. I just did the very top layer, not all top layers. Topmost layer only. It goes from a 5-hour and 15-minute print for 20 of these to a 7.5-hour print with ironing on. So it's 2 hours and 15 minutes of just ironing on 20 of these. So, but I'm not planning on bringing 500 of them. I'm planning on bringing like 100 of them. So I don't care. I just started in the evening and they're done when I get up. Okay, where are we? So let me clean up a few things. Are you gonna jump over there and get a Oscar jump? Jump over here. You want on your chair? Okay, I'll ignore you then. Hey, tactical printing. Okay, well, he's not going to. He's going to be contrary. Okay, we are on the Prusa Bear GitHub. I was looking for files, I think, yesterday, just making sure I had everything. Let's go back to the assembly guide. And what is that? Where was this assembly guide? That's what I clicked on. Ah, there we go. Read the assembly guide here. Iron is nice but slow. Maybe a clothes iron may help. Yeah. Hey, Brent. That's right. Happy Father's Day weekend to all the fathers out there. No longer able to make it to Murph, unfortunately. I heard that, Thunder Keys. I'm very sad. I will see you at Earth though, right? Okay, and I think we want to click here. We are past the frame and we're going to get into y-axis motion. So, still working on my freaking Prusa and Voron just on the Y motors. Nice. I will be at Earth and Vice. Awesome. Father's Day weekend was last weekend there. Where are you, Tactical Printing? What part of the world are you in? Let's see here. Felix is being a loaf on the table here. That's nice. He's hidden behind the power supply, which I'm going to move. Can I put these back in here? Or are you going to take them right back out? Hey, Rod. You weren't late. You were first. I saw so. Hey, Dext. Belgium. Welcome. He is camouflaged. Okay. I'm going to probably freak Oscar out, but whatever. Can I move this over here without you freaking out? Nope. Here's the frame, and it is nice and flat. That is from our work last week. But what I want to do is replace these PLA or PETG or whatever they are feet with the TPU ones I just printed. Hey, Neil. You were first to the pre-party. Yep. So there, and these are a slightly different design, and I need to do these this way because the T-nut is not spring-loaded. I don't think I've seen the combo before. What combo? So is this a Mark 3S with the Bear? Yeah, well, Mark 3S, 3.5. Is there a 3.5S? That doesn't sound right. It's a Mark 3.5. It's a Bear with Mark 3.5 electronics, basically. And you know, you have a 3.5 Bear, Rod? How is it working for you? I had some questions. We're doing it anyway, but I had some questions on whether the some of the firmware stuff needs tweaked or not, or if we can. When will it be the next big event? What, you mean like in-person event? Or next big stream? What event? I am going to Murph this coming weekend. And then I will be at a machinist show with Bill here in Southern California. I'm looking forward, Clow 42, one of the machining and 3D printing YouTubers is supposed to be there, so I'm looking forward to meeting him. Back from an RC plane air show. Awesome. Using standard extruder firmware worked without modification. I'm going to be using the BearExxa 2, the latest thing. So now that it's a little softer. I mean, not a lot of friction, but more than these hard plastic feet we're giving. Been a while since on... The kittens are huge, aren't they? Aren't they? I ran into, if you go back and look at what Trident Upgrades Stream 12 is when I introduced the kittens to you folks. And they were in a laundry basket here on the workbench, and they had room to play in there. They are full grown. They haven't gained, they're kind of filling out a little bit, but they haven't gained a lot of weight in a long time. Felix is approaching 10 pounds and Oscar is approaching 11 pounds right now, according to the litter robot scale. Okay, so we are going to pre-populate a bunch of T-nuts. So we're going to slide 6 into the top channel of the front extrusion and 5 into the rear. And we're going to attach the rod holders to the frame. So, what are you doing? What are you doing, buddy? So what I want to see, dude, there's nothing else in there. Yeah, that'll work. The T-nuts are hidden by the things, so that will work. Nice to see Felix up here. Well, he, like I said, you might not have come in here yet. Yesterday I was in here working and prepping, and I had a bit of the ooze from changing filament in this trash, and that is one of his favorite things to play with lately. And he remembers it being there and wants more. And Oscar naturally wants to know what Felix thinks is cool. Guys, keyboard, don't sit on it. It's like a nice sturdy frame. Yeah. I'm really pleased. Like I said, I'm pleased with how last stream went because we spent a ton of time straightening this frame, but we found very definitive reasons why it wasn't straight to begin with. So, very happy. Okay, we need to throw a bunch of these guys. So, these are the Y rod holders. Hopefully the Y rods fit in the Y rod holders. Let's see if they, yep, they snap in. So, it's a little bit of force, but that's good. And a bunch of 12 millimeter. These 12s or 10s. That's a 10. So it says 5 by 12s. Yeah, and a 10 is a little short. So pick out the 12s from here. There's a 12. So 1, 2, 3, 4. Front. Need 4 more. 1, 2, 3, and that's a 10. Is there another 12? Maybe here? Nope. There. Okay. Oscar's got a bit of raccoon pattern on his tail. Yeah, it's a tabby. I don't know what's a better view here. Maybe we go here. You guys are really wanting to be in on the action. Ah. Come over here. There you go. Of course, you hit the window key on my keyboard. There we go. Where did you get the extrusions? This is a nice blue. These are LDO extrusions. This whole printer I got from Chris Russel. Used to run a channel called Practical Printing. Used to live in Southern California and had to move. And when I was at Rapid TCT LA last year, he handed this over to me. My intent is to give this to the friend who got the ender wire that I built and grab the ender wire back. I think this will be better for his environment. He has it at his work, and I'm sure it's going to be easier to deal with off network than the ender wire. I like the LDO gray I have for my nebula. LDO's space gray is really nice too. So I want us to put this guy on. Yeah, this is another couple of, what do we got? Thread. Take the Y-idler mount, place one M3 lock nut in the pocket at the back of the part. Ensure the lock nut has been fully inserted. Losing the lock nut if you have trouble. Okay, good. Using M5x10s because I'm out of M3x10s. Take, oops, let's go here. Take this guy. To put a lock nut up in here. Oh yeah, that's probably gonna have a hard time staying there. So let's throw a screw in here. Oh, maybe not. It's got to be pushed in. All right, that'll stay in. That's not going anywhere. Oh, there's a 12. I thought I was out of those. Hey, Kobe. Gonna guess the ender wire is louder too. Probably. There's some measuring and placing that we're gonna have to do with these. How does this go? Looks like we need to put a T-nut in from the end. I think it's easiest to do this way. So let's go, put it right there, and boop. Oh, so close. Got it. I got it right to there. There we go. Bye. Screw went flying across the bench. Okay, leaving all those still relatively loose. Not fully tightening. Okay, so we're gonna take a rod, whichever one of these. I guess I'll just leave this view. I don't know if it's probably the medium length ones. Yep. And then all of these, I've already gone double check these to make sure we didn't have any grooves in them. We are going to need to take these off, but this is just for positioning the mounts. Oh boy. Is that all? It should actually snap in. There we go. So nope. There we go. That might be fun to take out, but we'll get it. Okay, so this will slide along here. I printed these guides that are mentioned in the manual here. I had forgotten to print those before, so I got those printed last night. I printed these on the Core 1 in that new Polymaker HTPLA GF. What I'm really liking, I did that mock-up for the mill mount. What I like about this is not so much the HTPLA part of it, but the glass fiber part makes for a part that's less likely to warp. Not as big of a deal on this, but it was a bigger deal on the larger piece there. So these get held in place and do like this. So if we go here, we'll keep it consistent. Does those rods not have a runner on? They do. I mean, are you talking about the bearing? There will need to be a bearing. I think the idea here is we don't put the bearing in yet. Just keep it out of the way. We could have put the bearing in. I think it's just for getting this spaced correctly. So that is, and I'll use the same one to double check, and that is spaced well. You should try out PET CF or PET GF. So obviously, I know you're distinguishing between PET and PET G. I think I have some PET CF. I've printed with PET GCF and like it. All the atomic stuff they used to, they still make, but used to do a lot of printing with the atomic PET GCF. Little Polymaker, but I have rough times with a filament roll I recently got with which clogged 3 printers. Yeah. It happens. I mean, I would be contacting support if you think it's the filament. I think a good measure of any of the anything is the response from a company for support. Yeah. Bearings go on the wire carriage, and then we'll have to pull these rods out though still. Okay, what else do we need to do here? Using the same, adjust and tighten the rear. So I printed 2 of them. The idea is use the same one and you're going to get consistent, but I checked it with the same one. Okay, prepare for the Y motor mount. Remove the Y smooth rod and slide T-nut into the lower channel of the rear extrusion as shown. So we do the same thing as the other one. So we're going to pop this thing out. There we go. I've heard Polytera likes to clog up for some reason. Some interesting conversation with Polymaker on the HDPLA and their standards on testing. Yep. Okay, and then we're going to throw a T-nut in the back here. Oop, too far. It just says to put it there. So we don't do anything with it yet. Instead, we're going to shift gears to the bearings. And actually, what we really need to do is make sure all the bearings are good and get them, let's go here, get them greased. I think it clogged an obsidian. There's some interesting, yeah. Where, hey buddy. Okay, I threw a bunch of stuff in here. Let's grab these. We're going to want to clean those. Oh, and there's a magnet in here somewhere. Some more idlers. Bearing. Now, Chris had said that this does not have a lot of hours on it. And it did not, none of it looks dirty. So we are going to... magnet. Throw this over here and leave these parts together. There we go. Now we'll never find it, but it's right there. If I want to believe the prior owner. I don't. I don't believe him. I think it probably has more hours. No, it probably has fewer hours than he's guessing. I know I always underestimate the amount of time I put on printers. This guy is shedding like mad too. We're going to have cat hair all over. There you go. I need, oh, grease. Okay. Oh, hey, are you like begging for treats? Is that what's going on? Make sure all of these, this one looks really good. So let's get some grease in here. I'm almost out on this tube, so we'll swap it here in a bit, but there we go. And where was the, did I put that right back there? Is this one of them? Nope, that's an X. It's this one. Yeah. I'm just gonna see how these ride on here. I'm gonna end up with a ton of cat hairs in those bearings. Mm-hmm. Yep. Okay, so that feels fine. And when I did this, there's no, like that one bearing that was bad, it was very dark, the grease that squeezed out. So I'm just gonna pull this. Call that one fine. It's gonna be a mess. Okay, so that one's done. Kitty fiber reinforced filament. We should have to suggest that to someone. I think Protopasta is probably the most likely to go for that. And hair smell lingers in the extrusion line. What is this? Bill, why aren't you on stream today? Oh, that was a special Unbox the Mill stream. It is a not insignificant drive for Bill to get over here, so it's not bad. It's definitely a within driving distance, but it's not a casual visit. Okay, we're gonna get 3 of these going. I don't mind the drive. Oh yeah. But it's just not something that's practical more than the occasional. Okay, we're gonna go with those 3. They all felt fine. There. Prep a bunch of these guys with, I guess we're doing lock nuts, right? Yeah, doing lock nuts in here, so. It was definitely a lot of fun. Yeah, I had fun. I haven't made any chips with the machine yet. I want to, the first chips will probably be on that steel plate, getting it modified. Let's get 3 of these going. I need to tram it. I need to do all that stuff. And although I could do that anytime, it just feels like I'll end up doing that before I actually use it. It is leveled. It is leveled. But it is not trammed yet. Okay. So there's some guidance on, pretty sure those are fully seated. There, this guidance. So we're now going to insert the bearings. When you place the bearings, you need to ensure that the rows of ball bearings have a 45-degree angle as shown. From each bearing is aligned vertically as shown in the first image. It's very important to have all 3 bearings correctly aligned. We're going to move on to this part. So, I think I always like the idea of marking on the outer flange of these for the bearing races, so it's easier to see. What is tramming? Where you're aligning the cutting, the spindle with the work plane. So it's easier to see and confirm after the these are on the rods. It's what we call leveling. So there are for a machine, a heavy machine, actually leveling and making sure what you're mounting the machine to isn't twisted is important. And then in addition to that, tramming. We should call it tramming in 3D printing too, depending on what we're doing. Did I show you here? Let me show a picture. This is interesting. So Bill left this because I used it later. We didn't get a chance to finish. This is a precision level. I want to show, I have a picture of, where did I post that? Oh, I posted it in Tool Chat. Yeah, for anybody who isn't in the Discord, this is a neat example of, I leveled my workbench here with a carpenter level, and then comparing that to the precision level. Now, if you look really close at the carpenter level, you can see it's not perfectly centered, but I hope I use that for my shed. That was just kind of neat. So thought it was a good demonstration of the difference between those levels. What's the difference between QGL and tramming on it? QGL is a tramming operation. QGL and Z-tilt is an actual tramming operation. What you're doing is making sure that your bed is within the same plane of movement as your carriage travels. Hey, Phil. So. Okay, those are all marked. We're going to put those in here with the marks like this. There we go. Shift it over so that there are in this print you can see those little grooves that match up with the grooves in the bearing. What's the angle tolerance on that? Is it marked? I don't know what the markings are. So this, you calibrate this by setting it down and looking at where it settles. So there, and then you flip it around 180 degrees in the same spot, and it should settle into the same spot. Now, I didn't pay that much attention to this, but then you adjust it with these screws here. So why don't they simply call QGL tramming? I don't know. Why do we use a lot of terms? At least as far as the probes your points your probe can detect. Well, the plane made up by the points that the positions you're probing at is what you're tramming to. And no, it's not okay. You don't only need 3 points on a 2.4 because 3 points define a plane. 3 points define a plane when you have a rigid object. A 2.4 gantry is not rigid, therefore you need the additional point to compensate twist. On a trident, you only need 3 points because you do have a rigid plane that you are adjusting to. As rigid as we can reasonably make it. Let's put it that way. Shift those in, twist them around. What is micro stepping? So on a stepper, you have a series inside of a stepper. You have a stator in here with a series of magnets around it, and you have the coils around the outside there. A full step puts you at a point where the magnetic field of that coil lines up with the magnetic field of the permanent magnets in the stator. Microstepping is adjusting the current such that you're holding the position in between full steps. Correct me if I'm wrong, that's my understanding. Maybe some specific terms, but microstepping is the stepper controller's ability to hold the stepper in between full steps. See you, Phil. Thanks for stopping by. Is a servo more precise? A servo has feedback. So the big difference between a servo and like a closed loop stepper is those have, between a stepper and a servo or a closed loop stepper is they have positional feedback. Thought it makes square signal more in line with a sine wave. Microstepping? I'd look that up. Okay, where were we? So I need the Y holder and square nut. Go. Is more torque a result of being able to actively adjust current to the device because you know that it is not holding? Or is more torque a nature of the way that a servo is built versus a stepper? To thread in an M3/18. Nope, that's 20. Thought it was close. Maybe this one's 18. Yeah, this one's 18. Here, since you're going to be up here, view of Mr. Felix. Okay, so this thing goes here, we don't tighten it down. So what this is going to do is compress this top piece a little bit to clamp into the belt there. Hi, Barry. Hi, Maurice. Okay, and then we're going to prepare the Y tensioner. So this is saying to use the Prusa idler. I think we're both right. Each step is a single square wave pulse. To smooth out the in-between steps, you play around with the current, which makes a sine wave. Okay, that makes sense. Current models are not as accurate. The idlers that this had on it before are these are 16 tooth equivalent. This is showing in the instructions. Oh, thank you. You hit the, this is showing the Prusa 20 tooth. So let's grab that. I've got extras. There's no reason not to use it. Server moves to a position, stepper blindly moves to a specific number of steps. But it can only move to a position because it has active feedback of where it is in a position. Let me look through my little bin of parts here. See where I need to go to find. Aha, I think I've got enough right here. Yep. I've got a bunch of these. So take this and this. And a dowel. Which dowel? Because this, yeah, this must be it. Coder resolve feedback for position. Okay, which one is the Y belt? Oh, I just grabbed them both, put them both in a zip tie because I was cleaning things up. Thoughts on smooth idler with the tooth belt? Good question. Hi, Selene. Hello. I don't think that the running tooth belts on a smooth idler is the source of the most common VFAs that are evident in some of these printers. To what degree it might probably depends greatly on belt tensions and stuff. I think given a choice, given equivalent bearings, that I'd probably choose toothed idlers, but you can also, used to be, you could get in trouble if you chose the wrong toothed idlers. There's two very close profiles that at least used to be more common to mix up. So you have closed loop and open loop steppers. I ordered an Ouroboros beta board from ABSx Tech. So we're gonna play around with some closed loop stepper stuff at some point. My rat rig uses smooth idlers on tooth belts, no VFAs. Exactly. There's too many factors there to where you couldn't just say, because you have teeth going across here and I have VFAs, that's not necessarily the cause. Like the hole cut up a power cord for using the wire to wire up the 120 volt main power to my power supply. Did it on my 14 gauge wire as well as ground wires. I do that. I cut up. I have piles of those of computer power cords. Wrong profile and the tooth idlers will make your VFAs worth. I would mention, what is the actual designations? There's, it's not MXL, because that's like a, aren't those the larger pitch profiles? What were the, I agree with you, Steve. My tooth idlers weren't wrong to my belts, caused issues. The tail is open loop, provides no feedback to the motor. Yes. We're wrong. Where? Okay. How do we? Okay, let me get back here. We need about a 650 millimeter belt, which, is it the long one or the short one? Okay, so it's a short one for Y, and that makes sense. Seems like it would go across a smaller distance. I said weren't wrong. Yeah, that's 650. We are, there is no writing on this belt, although it's going front to back. I don't know which way we would do it if it was. Put this guy around here, and this guy here. And put this in here. There we go. Autocorrect strikes again. Okay. Place the belt around the idler, insert the dowel. Grab the Y-axis mode. Oh, dude! That's the space bar on my keyboard. Dude, scroll back up. Where were we? Here we are. So there are, the Bear accommodates the previous printers that didn't use sensorless homing, had an end stop. There was a version. If we scroll down here, I think somewhere around here, there's a, I don't know where it was. Anyway, we're gonna put this on. What are we using? M3x18s. For not to use toothless idlers on a belt, I was worried the belt will get damaged under high tension. I don't know. Spacebar cadet. I know. They're doing that a lot lately. Motor mount. Motor mount. And these are not, it doesn't matter. These are the same. But which, yeah, this would be the Y because of the way the belt goes, or the pulley is on there. So this was the one used for Y. We are going to go, I think we're just going to go straight down. Maybe we can go straight forward. Down, forward, down, forward. Since we can, straight forward is going to be easier. I'm going to go straight forward. This guy goes on here. And then I need 3/18s. So does it make a difference on your drive pulley on your stepper motor on, say, a Trident if you have a 16 tooth versus 20 tooth as far as print quality? Obviously, you have to change some stuff in Clipper. Difference on your drive pulley on your stepper motor. You will get more torque from a 16 tooth pulley, but not as much resolution. So you're better off with the 20 tooth. We're not lacking in torque on any stepper you're going to use. There was some, we did at some point ages ago do a stream where we tried some 30 or 25 tooth pulleys, and you just needed higher torque steppers to make sure that those ran fine. Okay, 18s. I did not clean out and organize the fasteners in here. There's an 18, so now I just have to find two more. That's a 20. There's an 18. And this guy. What are you doing? I think we missed him playing with his tail. Wait, let's loosen these up. Ooh, buddy border's near 100C. Ouch. Okay, that's there. Put that on with M5x12s. I knew I saw another one here. Where'd the M5x12 go? There's one. M5x12 on top and an M5x16 on the bottom. I do not immediately have a 16, but I do have these low profile screws in my inventory. Low profile, it's actually a 15. I think that's fine. It's out of the way. This over here, I'm not going to use those. And the pin. So we need this and this. There we go. There we go. Hey, Kyle. Welcome. Is that correct? Hard to see if I'm lined up back there. Nope, I was not. Whoa, did you chase yourself right off the... I think he startled himself. I think he chased himself right off of the chair. HTD belts have round teeth. That's what I use for the cog belts on my bigger equipment. Got it. Ordered 20 tooth from one of our favorite vendors. Ordering parts from, I received 16s and didn't even count or realize until I was in the setup process and clipper. Oh, ouch. I mean, in a pinch, to get it running, you can run it. You going on a little roundy round ride? You are all the... I'll have to look. I'll have to watch that back to remember the timestamp. How far in are we right now? Let's see. We're at the right before the 1 hour mark. Okay. Oscar is using up every bit of that last brain cell. I can see it's we're about an hour in. When will it be catnip time? Tomorrow. We'll do that public. Although I don't think we need it today. Okay. Yep, that, and then we're gonna get the bed going. Get the bed ready. Over there, put this here. Oh, where did all this stuff go? I think we need to change out the wires on the bed as well. So let's get that. Yeah, we're gonna need to we can do the bed frame first, but when we put the bed on, we'll need to do the wires. So which is the top? So you can tell, should be able to tell the top for sure by looking at there's no indent there. There's an indent there. That's where the spacer was. So right there. And then what are these? M3/25s. We're going to have a bunch of these. Well, 6 of them. It's a bunch, right? Just... one brain cell is on lease at the moment. Okay, I found 4 of them. 5. One more. You? 6. Okay. Just realized that it's an anniversary stream number 40th. That's right. This is the 40th Charlie's Angels stream. That's pretty awesome. I feel like we've done more, though. I wonder if I screwed up counting at some point, because I know we've doubled up more than 4, more than 4 or so of these. Let's place to order wire for making power wires for the steppers and other connections. But we are 1 behind because I didn't do a Charlie's Angels stream until the first full month of memberships. So that might explain some of it. Best place to order wire for making power wires for the steppers and other connections. Oh, there's a lot to that, Fegley. If you want individual wires, and you're looking for PTFE, then just kind of see if they advertise the strand count. So the better quality PTFE wire is going to have a higher strand count than others. I don't remember what the number is for 20 gauge. I think it was 19 strands or something around there, but you'll find some with like 12 strands, or for 24 gauge. These in. What are we looking for? We're just making sure that these are all centered in all the ways. Bill, thanks for being a member for 37 months. That seems like an awfully long screw. It's 25 millimeters, sticks out a bit. Does that seem right? Start tightening. Don't want that to be tight yet. I'm afraid that a 20 is going to be too short to capture the... Let's see if we can get a focus on this. Come on, you can do it. There we go. Let's see, that sticks out that much. I feel like a 20 is going to be too short. If I had enough 22s, then that would work. Let's find out. I don't think I have enough. Nope, that's 20. Yeah, I only have two 22s, so we'll just leave it. Leave it sticking out. It'll be fine, but... So I'm looking to make sure the gap on either side is even and all the... Been running it with 16s. I've printed a lot of parts for another trident I'm building and getting great prints. Yeah, I mean the difference in resolution between a 16 and 20 is not going to be significant. You'll be fine. Joey, I was printing the PCCF parts for Cascade here on my gray Trident, the one with the orbiter tool head, and I have towels over the frame to get that chamber temp up, and at 65 or so C chamber temp, the orbital was reporting back. I saw as high as 106 Celsius on the orbital temperature. The only time I had a failure was the first time it hit that, because it was over the max temp set in the config. I upped the max temp and kept going, and I haven't seen any problems from it. I was just letting it run. It would run for full long prints at 100 plus C. Okay, so all of those, so I could probably tweak a little bit. Go. Yep. Pulled the cover, just dropped the fan. If YouTube hadn't screwed up my billing, I would show a member for 40 months. Is that the most right now? Has it hit 40 months yet? Okay, check whether bearings can slide along the slot. Bearings incrementally, screws until you can't move it anymore. Do not over tighten. Bearings not moving anymore. I see. So we really want to make sure we're not over tightening these. So I'll take a quarter turn, but nope, that one's loose, so we can feel it. Okay, so I can move that one. I can't move that one. I can move that one. These these LM bearings are very sensitive to crushing them. Okay. There. Little tiny increments. There we go. Hey, Queasy Diver. I like the rubber spacer they added on Mark IV. I agree. Okay, which was... I keep putting all these rods back in the same spot. So this one and this one. That looks good. Smooth rods installation. Gently insert the two on the one side, the one on the other. That'll set the spacing on these guys. These guys are still moving. Oops, the back one should move. Hey guys. Nice. Oscar bolted. Okay. Very easy to crush with the U-bolts. Agreed. I do like Prusa's new setup. Whoa, that is awful. That is awful. Why is that awful? That was not awful when I... Is that just a matter of it? Let's see what happens when it's on here. It's hard to make sure that you're pushing evenly. Let's get that in. That in. That. Yeah, that's better. I think it was just very easy to tweak that rod. Slowly tighten these down. This one, get it all the way over here. There we go. Feels good. Yeah, I'm fine with that. Trim the bare Y carriage I found to be a little annoying. Well, I think we're all good right here, just as it is. There's no, I don't feel anything in the bearings that's weird. Okay. These are not the, I don't believe these are the rods and bearings that came with the source printer. I'm pretty sure these are the something different. There's little bits about them, the texture on the rods, the particular bits of the bearings. Okay, smooth rod alignment. Never use a build helper with the right smooth rod is made to align left. If you have 200mm caliper, you can measure the distance from the smooth rods directly on the metal. The spacing of the smooth rods is 170mm. So we should have 178mm between them. Let's see. That's what the instructions say. Let's turn this to send that out. Sure we're even. 178.04. If we squeeze it, we can get it's 178.0. Yeah, we are. Oops, sorry. You can't really see it, but it says 178.05. Given the same tension on it. So yes. We are perfect. Okay, what is next? Y-axis. Okay, so here, set the Y-idler mount, 51mm for the Y-idler mount, and 48mm for the Y-motor mount. So 51 for the Y-idler. Oh, look at that. TJ. 1mm plus a cat hair. Well, yeah. And then 48 millimeters. I'm on a roll today. Yes, I know, it's scary. Something moved, it's scary. Okay, so we're measuring right there. Should not have been tightened. I'm coming. Where are you? Where's the screw? There we are. 48 millimeters. Okay. Adjust these positions if necessary after the belt's in place. Put this on. It's 2 and 3x10s. Then we're going to get ready to route the belt. So, this on its back like this. Here we are. So, there, and 2 and 3x10s. He loves jumping to the chair and it slides. You see him down there. Okay. So this is going to go on here. What was that? My phone. Okay. Remove. Verify the orientation. All that's fine. Everything's good. Remove that in 3x25. Add a washer to the screw. Oh, that's where that washer. Another M3x25. Is that this guy? No. M3x25. Might be one of these. Yep. Washer, what goes on the bottom? Insert an M3 lock nut on the left side of the idler mount. Ah. Wonder why we didn't put that in before. And what is this? M3x30. This guy? Yes. Okay. Show this. Wrench access hole, I think, is what that is. And for the head of the screw, let's get the cat hair out of the way. This guy's gonna go up. Is that gonna press in there? Press in there. And thread that for a little bit. that much adjustment. Screw until there's a small gap. Just belt it. It's not much to it. So let's turn this back around. This guy goes in here and here. This will come around. Get that in here blind. Hey, don't knock it. So this is going to need to be pretty close to tight to begin with. So let's get that there. This one, a couple of teeth more. Get it tucked up in there. We'll try this. Push that all the way in. If it's still too loose, we'll pull one end out and cut a tooth off the belt, because those are all the way into the end of the space there. Make sure this is loose. Yeah, that's loose. Make sure we can get all these all the way down in there. Tighten this down a little bit. Just needs to be just snug. Is it an orange or black hair, Steve? Well, Oscar is shedding a whole lot more than Felix does. So most of them are light orange hairs. Okay, so with that there, move this back, put our little tensioning screw in here. And I don't know, we may have to pull a tooth because it's pretty much fully bottoming out, it looks like. Let's see what tension we're at when it does that. Oh. Ugh. Not a lot of space here. Actually, we're okay. That's a little too tight. So we have a little more to go. So I'm going to call that good. Cool. Call that good. We'll final tighten that later. Now I'm going to run this along and watch the path on the pulley. And it wanders a little bit, but it doesn't actually touch on either end. It stays within the center of the pulley. So we're going to call that good. YouTube live streams are one of the very few occurrences of live TV watching in this age of VOD. Yeah, that's true. Hey, Boydie. Welcome. Okay. Verify the belt is fully inserted into the slot. It is. So y-axis parts refinement. That's what I just kind of checked. Things seam. What do we? Apply a light tension to the belt to remove any slack. Do not over tighten the belt or adjustments. Adjust position. Remember that when you tighten the either mount and wide motor mount screws, you must do so evenly. If you don't do this, you may cause those parts to be misaligned. I think we're okay. Okay. Zip ties. Note the orientation of them. We don't really, these snapped in pretty good, but yeah, we'll put some zip ties in there. Where are the zip ties I was using? Where? Well, here. But I have more. Hey, Mr. Tiberian. Making my first foray into nylon printing today. Have fun. How nice. Okay, need to find, where did I put zip ties? There we are. These will work. That is first gen Mark III era zip ties. It's kind of funny to know that. Okay, what are we doing? We are putting them this way. There we go. You are very antsy, Oscar. Are you very acutely aware that it's treat time? Is it treat time? Catnip today, catnip tomorrow. Gotta do that public. Do that public. Can I have my mouse? Woohoo! That sounds like a good time to get some treats. We're on to the Z-axis. So we have the Y done. Let's do some treats. 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 Treats, Felix. You can follow it. You follow it. Follow it around. Yes, you're funny. I'm funny. A treat. Nope, 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 nope. You get your own. Come here, come here. Over here. Over here. There you go. One more. Hey, don't bite. You lick. Ah, funny. Ah. If I sit on the frame, he'll give me the treats. I'm training them well. Okay, where are we at? We are on to the Z-axis. Engineer solder vacuum arrived today. How do you like it? That was really quick, Bob. Okay, if you check the Z-axis parts during the pre-flight check, then you should do it now. You may have problems. Note that this chapter images will only show... So what am I looking for? Oh, I think are we checking for fit for the rods and stuff? Let's see. Pre-flight check. I want to see what they wanted us to do in the pre-flight check. Verify the Z motor mounts. Verify the internal surfaces are smooth and flat. Okay, that makes sense. Clean up if necessary. Verify the surfaces that will be in contact with the extrusions are smooth and flat. So this is all critical. This is all very important stuff. So let's check all of that. We definitely have things like pressure advance that impacts how these are going to fit against the extrusions. And pressure advance was not perfect on these, so it's worth checking. Speaking of, what tool was that? What tool? What tool? Tool was what? Did I use a tool here? Used the cheap ones for years. This is worth the extra. I told you. We're talking about the engineer's soldering. I'll give a view of one. I've had this one for, I guess, 6 years now. This is the engineer's solder sucker. Spring loaded, but nice thing, it has a silicone tip here, which helps you get a little better seal. It is replaceable, but it's just nicely machined. Good. Let's see something. Yeah. Oh, sarcasm? Oh. Fell asleep watching a video one time, rolled over my phone, and apparently clicked yes on the trial for YouTube Premium somehow. I'm on YouTube Premium. I just don't want to deal with ads, and I'm benefiting from it, so. Another tool to put in the cart. There's a possibility this one might actually be in my Amazon affiliate store, which links in the description. I don't know for sure. Okay, I need a file. I want the other file. Where's my flat file? There it is. Okay, so we're gonna go through all of these and just get the peaks down under here. Just make sure there's nothing sticking up that's gonna make the stepper sit on there skewed. And then along the back, I'm just gonna run this up, and this is all gonna be hidden because this goes in here like this. Buy the extra silicone tips, a neighbor has one. I've had that, Bill, since 2019 is when I bought it, and I've not gone through a silicone tip yet. That's good advice, but I have not had to do anything. You can see where it's getting the peaks there and just evening things out. Then we can be somewhat a little more assured that this will set flat against the extrusions. It's not in, no, it's not. Okay. But if you click on there now, when you go and look at it, search for it, I think it'll apply. I have a annoyance with my Amazon affiliate stuff because I tried to do something else for another purpose and it's confused things out there. everything's okay, but it's not, it just makes it so I don't want to go in there and deal with anything. The thing we're going to check is the rod fitment in these and ream them if we have to. Okay, so then should be able to get these guys in here. And it's too tight. It's too tight to fit that in there. So we'll grab a reamer and clean that up. This is 7. Ow! Just jammed my finger into something. There we go. So if we go in here and just, I mean, it should be close enough to be able to do this by hand. Maybe the neighbor isn't using his correctly. His gone through 2. They get all burnt and don't seal well for him. Interesting. I never run mine right against the iron though either. So maybe that's it. Usually if you've got a component on the bottom of a something, what do I have around here? I don't know. This is just a little fan PCB, but I'll run my iron, say, on this side and bring this in from this side to where it's not really setting directly on the hot iron tip. So I melt the opposite side from where I put the plungers, or the sucker is the idea. Okay. Iron temp, yeah. I'm almost always right at 600 C, or 600 Fahrenheit, I'm sorry, for my iron temp. I don't usually adjust that much. But I'm also using actual lead, old lead solder. So I think, is it right? The lead-free stuff needs a little higher temperature, typically. Make sure I get a good smooth. I don't know if it's as important, probably not as important in plastic, but reamers are supposed to be ran just in one direction, just clockwise. You don't want to run a reamer backwards. Good results with lead free though. Gotten used to using it. I've been using the same spool of solder for 20 years, so if I wouldn't have a problem with trying lead free. I just haven't had to. Okay, those are all cleaned up. So I think we're ready to get back to this. Back. Okay, we are going to throw that thing on. So I printed some stuff that I'd missed, and these little protection pieces were some of them. So we might need these soon. Those other ones can stay there. usually solder at 650 Fahrenheit for PCB work. Same roll of solder. Yeah. Okay, now we get the steppers. I think we already kind of cleaned these up before because they look pretty good right now. So these little pieces can thread onto here, hopefully. Let's see. A little dust cap is all. Main sale update. Anyone here remember Incredible Universe? Incredible Universe was, that's an electronics store, right? And we had one here. It turned into a Fry's, but it was prior to me moving down here. I never went to Incredible Universe. The one here in Sacramento ended up turning into a Fry's. I'm cleaning these out because apparently my mind says we're working on lead screw stuff, so lead screw nuts, it's time to clean. There's some crud in there. So I probably bought my roll of solder at Fry's, Joey. So at least the roll that I'm using right now. This is the stuff I'm using. Quality. Is that what it says? Qualitech. Qualitech International. Addison, Illinois. See material safety, data safety sheet. No clean, 6236-2. This is the stuff I use. And I've only been through that much of it. Okay. It's my dad's roll of rosin core solder, which was bought somewhere in 1942. Holy moly. Okay. Loves that jump. Okay. Z motor insert in 5x10s. Thread 2 T-nuts. Place them vertically. Repeat. Repeat, repeat, repeat. Let's take this guy. This guy. So these go here. And then to grab tens. Oop. That. Okay. Put those on here. make sure everything's... Okay, so this one has a lead screw to the outside, or the, not the lead screw, the linear rod. Should be able to push these that way. I think these go all the way to the bottom, just rest on the... If you have the original Prusa spool holder for that bear, made a part for that. Oh, I don't know what I have. I have a bunch of spool holder stuff. If you want to send me something, if it's useful, I'll see about using it. Just an adapter that sits on the extrusion at the top. I will probably set it up such that it has a spool holder off to the side, and then a filament guide tube. There's another one of those. We use the term leveling. We use reverse Bowden incorrectly. Or we use the term reverse Bowden in the first place. Reverse Bowden. Filament guide tube is a more accurate description. Okay, tighten the M5x10 strongly. Make sure I'm strongly. How many ugga duggas is strongly? I'm gonna say a full, maybe an ugga dugga and a half. Put the Z motors in, those get held in within 3x10s. At least 3? I have to break the fart part. Okay, so then, how are we gonna do this? We'll do this to the inside. I want to do something with this printer. I want to put in slot covers. I want to do the whole prevent dust in the thing. I don't think I'm going to need to mount anything to the tops, at least not in the front. I'm not sure about the back. Let's see if we can figure out. I want to kind of skim through and make sure we don't have anything on the top. And I think putting these in now, the little slot covers, is going to be easier now than later. So heated bed, let's go to the chapters. Let's see, axis, let's go. Is that what I want? No, I want full, like, I guess I'll just scroll through the whole thing. So Z-axis, that's where we just were. We don't need anything here. Let's go to the heated bed. Make sure there's nothing weird here. I could open up the CAD too, I guess. LCD screen and PSU. That just goes to the front there. PSU. So this is where we would want to double check. So we do have the black PSU. Just goes on the side. This is silver. Let's go down to black. Where's the black PSU stuff? Silver PSU, where's the black PSU? If you have the black PSU, go to step 11. Here we are. So we have that, which are those, and then we have a lower mount. Lower mount goes to the back extrusion. So that covers that. Nothing along those tops. Okay, and then the electronics is electronics would be the other one. Now I'm using a different electronics than this is set up for. So let's look at this for a moment. We have electronics thing here that I'm pretty sure mounts up higher and is not going to interfere down here either. So let's put those slot covers in. I think I'm comfortable putting in the slot covers. Where are they? Where are my extra bits of that? See if I have any. Aha, here we are. So I ordered 22.5 meters of it from OpenBuilds, and I got it. Nice going out of business sale prices. They're in the other room though. Okay, so this is the slot cover stuff that I like to use. It's from OpenBuilds. You can't get it anymore, unfortunately. I need to find another source. I suspect that you can probably get it from Masumi, but I'm not sure. This is nicer than the soft silicone stuff that you can get that used to come with like CR10s and such. Yeah. Now I placed an order for a bunch of stuff and the order got royally screwed up. They have responded to me. They are going to work with me. It may end up that I just end up getting a refund for the stuff I didn't get, but I'm disappointed because there were some end mills and some of their wiring that I had ordered to go along with it. So we'll see. Anyway, this is basically going to have to go straight. So we're gauging the lengths that I need. This and this. So like head bolts on an engine, tighten it again, then tighten a quarter turn. Torque to yield. Torque to yield is what that's called, right? It's very specific. You tighten it to a certain amount and then an additional however many degrees. Okay, so that should be for this inner slot. And one of the nice things about this is it goes right underneath that. There we go. There's one. This one is going to be a little different. Let's see if I can get a estimate here. Okay. It's going to be the same, but minus about 18 millimeters because it can go. Yeah, it can go underneath that. This should be about 20 millimeters wide. Is that right? Yeah. So let's mark this one to the full and then make it 36 millimeters shorter. Maybe make it like 35. Let's go right there. It's just easy with the X-Acto knife to make marks that you can see in this stuff. Let's see how good I did there. Oh, I think I did over. Shoot, I wanted to go the other way. So 70 millimeters shorter than this. Oops. 70 millimeters shorter than this. I went the wrong way. There we go. This goes under, goes in there, and off by quite a bit. So I'm gonna mark this where I think it could be. And I'm going to, that that just happened to end up almost exactly the right length to this one in the good direction. So let me mark this. I won't cut it yet, but at least it's marked. We only have to measure one side there, and then we tuck this in. There we go. Cool. So that works. And now let's cut this bit off the end. And since it's a small bit, it cut at an angle. So we'll fix that real quick. There. Think I cut it correct, but kept the excess in hand? Oh, it could be. In any case, we're getting there. Another piece. Go right under there. Now I've got these top covers protected from just debris getting in, and I'll end up putting ones along the top in the front here as well, and wherever I can fit it in the back, but that just keeps things a little cleaner. This one could have been a little longer. Annoying that that's a little rattly. That's okay. It does the job. What is next? Let's go back now. Back. Heated bed. Is that where we're at? No, we're on the Z-axis still. Those go there, and then the steppers can go on. Now I'm going to put the wires to the inside, I think, instead of pointing front, and you can't get them to point back. So I'm going to put that there and this here. Those will end up sucking up in there. Don't throw away those cutoffs. Oh yeah, I threw away the one that was this long, but I keep all of these. These are so handy, see? It's plenty to fit in some of these spots. And 3x10s. Short. There's a 10. There's a 10. There's a 10. Okay, that's all the 10s that I want to use in there, so I need more. 1, 2, 3, 4. Rules of cutting. Measure twice, cut once, cut biggest to smallest piece. Cut twice and it's still too short. I like one of the clever things Prusa did with the Mark IV was the little rubber spacer here, and then using that to adjust the position of the Z steppers. Go. Let's see how all these line up when we're done. Added the rubber spacers to the Z motors on my bears. Nice. We'll see how this lines up when we're done and see what we want to do. Okay. Here are the Z motors in place. Note the previous bear used in 3x12s. Previous version of the bear, original Prusa are using a washer. The motor cable should be oriented towards the inside of the frame. Yep, so that's what I did. That's what made sense. Aha! X-axis. It's gonna be a fun part. Lots to do here. So we're going to want to clean up 3 more of these bearings. Clean and grease. And I also use the 10mm rods and MK4S blowers. Oh, Okay, we have got... Okay, so the instructions here say in this step we prepare the X-axis for later assembly. If you're using the BearExxa X-axis or the original X-axis, you will need to unscrew the smooth rod tensioning screws as shown. That's these guys. We are going to skip over to the... Is that right? Do we skip over to another part of a different GitHub, a different thing? Let's go here. We don't need this. That is Prusa Bear GitHub. Remember, we went here, and this is the main page. But if we go back, and we're gonna do the I think this is just the extruder. I think we need to look at this one different. Let's see. So this is what we're gonna build with these ends. Let's go to assembly guide. Quick assembly. Let's see if this is. This is all useful, but I don't think we need it quite yet. Yeah, this doesn't cover the other stuff. Still using just double checking things. I think we still use 3 bearings, right? Or do we have, is this 1 bearing up here? Trying to figure that out. Is this 1 bearing? Is this a long bearing or is it 2? Or does it matter? Two on top rail, 1 on bottom. Even with the new setup, this is the new one, Bob. I was just trying to confirm that, but unfortunately the instructions, maybe it's further down here. Maybe I just wasn't, maybe I skipped by it. I just wanted to confirm. Yeah, everything shows this already covered up. There's no pictures without that cover on that I've found so far. Yeah, that's funny. Okay, so let's go back. We want to go to the Bear extruder and X-axis. The bomb would tell us, yeah. I don't actually have. Let's go. Features, disclaimer, 2 bill of materials. Bearings, LM8UU 4. Hardware X-axis, hardware extruder. Three, yep, LM8UUs. Confirmed. Thanks, Maurice. Okay, now we're gonna go back to the extruder and X-axis and manual. and assembly. Here we are. Okay, so we have all the parts. We're not gonna do the extruder part of this, but the x-axis part we will. This is all pre-stuff. So x-axis. I want a cake, but I don't want to bake. Okay, so we have these parts, and we're gonna throw in some regular hex nuts. These guys, and we're gonna throw hex nuts in here. This guy as well. Okay. Hey, zombie. Welcome. Welcome. How are you doing? You ready for your Indiana? Let's grab a suitable length screw here to pull all these in. Oops. Nope. Mostly packed, actually. Nice. I have nothing to get ready, and I haven't packed. I am not prepping anything for it. I am just attending. Ah. That one's kind of a bear to get in there. Pun not intended. Let's see if I can get that. No, I can't. Oh, maybe a little pinky in there. Push that up. There we go. Considering packing clothes and everything already. You're excited. I'm excited, but not excited enough to be packing already. Need a vacation from work. Yeah, me too. Me too. Still hoping to clear the schedule for Vice PDX. Cool. I will be there. I'm debating. I'm keeping an eye on airfare for Formnext this year. I'd like to go again. I don't know if it's going to happen. It depends on if airfare hits a reasonable price. Okay, those in there, and there. So then we've got the bearings, and we want insert into until the internal stop. The next bearing will have to be inserted so that the rows of ball bearings are at 45 degrees to the rows in the other bearing. Insert that bearing onto the, verify the rows are rotated. Okay, so it looks like they want us to go straight and then 45 degrees, but we need to clean all these up. So let's just get all of these cleaned up and ready. You're going to be at Portland Vice? Cool. Okay. What is that? That is fine. Okay. Go. Let's just get this guy here. There's a Portland Vice, yes. Yes, there is. There's a Portland, Maine, right? Not Portland, Maine. Yes, Portland, Oregon. I know Portland, Maine would work really well for you. Okay, cat hair's out of there. And then this guy is going to go in. Okay. Show up through here. And angled. Oh, yeah, that's what I should do. Where's my marker? So we can check these. Love Portland. Awesome. I need to book my hotel room. That one is cleaned up. In. Straight through like that. And then we'll clean another one. So something to keep in mind in general for folks is that the Voron International Community event is very specifically intended to be non-commercial. So it's very much a Voron enthusiast hangout. There's no vendor sponsors, that kind of stuff. Oh, what do we got? I have a cousin in Portland, Maine. Portland homes the Unipiper. What's the Unipiper? Where's my cap for my... Oh, there it is. Okay, now this one goes in 45 degrees to the other one, so it'll be this way. Oop, that did not stay the way I wanted it to. Let's see if I can. There we go. Hey, Killer Prince. Killer Prince. I started an email conversation with Nathan today. Unipiper. I'm going to look at Unipiper. Oh, that's hilarious. That's hilarious. So for those of you that might happen to not know, There's a Discord link in the description. If you link, I had reached out to Nathan Killer Prince, so I don't know. It wasn't a general notification. I had reached out to chat about stuff. If you don't know, there's a link to my Discord in the description. If you link Discord to your YouTube account, then it will auto assign you the Charlie's Angels role and give you access to an extra stream chat. Hey, Kenneth. Okay, so that is that one. That one is done. And then the temporarily through both, engage 2, M3x10, alternatively tighten them and don't over tighten. Okay, so we're gonna temporarily stick one of these up through here. And that's nice and smooth. So 2 M3x10s. Run out of M3x10s in this box, so I'll grab them from here. There, just touching. And then dirt, and dirt, still smooth, dirt, and dirt. I think that's probably enough. We're just keeping them from being able to work their way out. So that is good. And then the motor end. So basically the same thing. Hey, Youngtik. Don't forget to like. What do we got? We have 69 people here and 38 likes. What do we got going on? All the way down there. Okay. What time is it? 12:30. Expecting to finish the Core 1 build tomorrow. So I'm hoping, my hope is that I finish early enough that that we'll start a print. And while it's printing, we're going to play around with trying to crimp Molex ClickMate connectors and make a internal harness wiring adapter for the accelerometer. So I have all the terminals and connectors that we need. And we'll go from there. So while it's printing, we'll figure out what that's going to be like to do. It's fine. Yep. What are you working on tomorrow, Killer Prince? So for anybody who doesn't know, Killer Prince here streams before I start on Sundays. Sunday mornings, doing builds very, very similar to the what I do. finishing up the inertia cube, knocking out the wiring as you type. Nice. Okay, so I am going to go the same way on this one. Put this in this way. Too much. Where did I put those? Not squeezing, just giving, it's just a little easier to control. There we go. All the way in. This one at 5-degree angles from that one. There we go. 2 10s. Put this guy in here. Everything feels good. Let's tighten down. There and there. Having trouble making microfit connectors. Can get one set of pins in, but not the others. Are you talking about like one side of the connector, as far as like the male side or female side? Okay, it's all good. The Knipex pliers are smooth jawed. I just used it for the extra little bit of friction there to be able to hold it and twist it. Begley, if you look at, let's grab a 4-pin. Grab a 4-pin. Maybe this would be the camera. Okay, we have connectors and we have terminals. So we're looking at microfit MF3 connectors, and this would be the male housing and female housing, and then we have the male terminal and the female terminal. So pin and socket go together, right? The pin side goes in the opposite of what you might think. Socket side goes in the male side. Now, when you are putting the pins into the housing, if you look at the terminal, the wires go in from this side, and if you look on the terminal itself, all the parts that crimp, so those point up, and you crimp them. So if you keep the crimp side up, it goes in like this. Crimp side always goes towards this tab. So you see that? Imagine that's crimped. It goes up towards the tab. Same thing on this. So you have the locking tab on here. The crimp side goes up in there. Now, I've always had a more difficult time pushing the terminal into the housing on this side than on this side. Often I'll grab a small screwdriver, small flathead or something, and push against the side of the terminal to get it to push all the way in. See you, Neil. Did that help? I don't know if that was where you were going with your question. That helped or not? And when you screw it up, or you need to reverse it, these are your magic tool. This is the JR Ready Microfit Pin Terminal Removal Tool. That one is in my Amazon store. I won't actually demonstrate that because we need to keep going on the build, but I wanted to try to answer your question there. Okay. This is an example. This is a Mark 2.5 with a, do you have the 2-part anvil for crimping, or crimp the wire and insulation separately? I do them separate, George. I use the iCrimp 2820M crimper. That's my preference for almost everything. Except for DuPont. DuPont, that's the wrong crimper for DuPont. Okay, so now we can put this on, check the holes in the smooth rods, go all the way through. And then, oh, we will be checking to see if these even fit. So this is the longer of the rods. Do you have the, oh. So we're going to see if these even fit or if we have to ream it out. That is never coming out of there. I probably should have reamed it. We'll ream the other side just to make sure. That helped me. I could never tell which way up on those microfit terminals. Good. As long as it helps somebody. There we go. That fit. On this side, because the way this works for the way it assembles, something that Greg did different from Prusa, is there are screws that go in the end here that ensure that your belt tension isn't going to pull these in and cause it not to ride straight on the Z rods. So we want to make sure that this can move so that those screws are effective. So I'm going to use the reamer on this side. So it's already very close. Just printed a full plate of PLA HT glass fiber part, Prince Line Dream. Have you tried this yet? I have. It actually prints really well. And I was talking about it a little earlier. What I'm finding I like it for is I printed something like this, which is a adapter for my mill back here for the auto feed. And being a filled filament and PLA, you have a low shrink rate, and with the fill, it resists warping even more. So having a high confidence of getting a test part, a mock-up part off of the printer that isn't going to be dimensionally different from what you expect and isn't going to warp, I think is an advantage to something like that. So that was what I was using it for. There we go. Get that all cleaned off. Does the glass fiber help with the usual PLA creep? I wouldn't think so. I wouldn't think so, George. Cat helmets. Sure, get rid of all this debris. And we'll see how that worked. Yep, there we go. That is a nice, not loose, but a nice little bit of effort to put it on, but it goes on and off really well. Okay. Then we need to do cleanup and grease the X rods as the last ones. See if I can squeeze out 3 more bearings worth of grease from here. One more. Get a little bit more in this one. Yep. All done. All of it. There we go. That. Done with that. Now let's mark them. Getting that last little bit of toothpaste. Exactly. Very much the same. Okay. The bottom. Needs the reamer exactly 8mm or a bit less. Well, this is not a super, not a high-end reamer set that I have, and it's fine. It's marked at 8mm. I have purchased some some fractional or more precise reamers for other purposes. You can buy like a 4.1mm reamer or 3.9 over or undersized. I did that for some reason. I don't remember exactly why, for the black box build, I think. But for these, for the purposes of what we're doing here, just the generic set. KB3D in the US sells a nice set, and they include a cool laser cut holder or laser cut and engraved holder for it. But you can get them off Amazon and stuff like that too. The big thing I'm doing here is just kind of working the grease through, but also looking at what squeezes out. If it was dirty and dark, then I'd have a concern. But everything that's been squeezing out has been, it's a little cloudier than what goes in, but that's probably just air getting mixed in with it as we work it. We work it. Okay, so that should be able to go on there and make sure those don't fall off. Okay. Hey, John. Welcome. Be careful, insert a nail in linear bearings. Smooth rods assembly, that and that. Ensure the smooth rods are fully inserted. It's too hard, and you can use a quality metal drill. A reamer is better than a drill for this. It's very easy to accidentally complete. It's very easy to accidentally complete the end of this hole to drill right through. So a reamer does not have a cutting edge on the front. It's flat. So this will not go all the way through. If you put this in a drill and push, it'll cut through, but it's not going to pull itself through like a twist drill bit will. Okay, now we're gonna put the X motor on, pointing down. That is with M3x18s. And yeah, what is that? Finish to tighten while applying gentle pressure in the direction shown. I see why. So the reason Greg's telling you to put gentle pressure is this little feature here. What he's ensuring is with the V feature here, it is ensuring that this is going to be vertically centered along the belt path. And you're not going to end up with an unexpected angle on the belt. So you're pushing this part of this step on the stepper up against that plastic feature to constrain it. Okay, that's 1, 2, 3. Yep. Wires down. This is going to go here. See that V feature here. Oh, okay, just get these started. Pull that into that V. Go. Get that step. Let's see the step pushes in there. I mean, there's always going to be some level of slop in these screws. That just gives you a, make sure that you're not slightly off. Okay. And I'll adjust the position of that pulley if we need to. Okay, X idler. So this is the same. Insert the idler, press the dowel pin through. I'm guessing that this still uses not a 16 millimeter, not these small ones. Can't be worse than an under 3 belt path. No. Hey Keith, welcome. Where did I leave them over here or? No, yep, I left them over here. These and this guy. I need to put a couple of lock nuts in here. Nylon side of the lock nut facing this way. Okay. And the other pin. This side. Yeah. Ah, there we go. Right through. But I have a couple of little pieces of. There we go. Okay. Put that in there. Secure it with two M3x18s. Now, I found that this really, even if it's not intended to be, there is a certain way that this goes in and slides a lot better. And that's I got it right the first try. But there's a certain way it goes in and slides better than, I'll show you if I flip this around. Oh, that's the way that it goes, see? It slides in all on its own that way. Turn it around this way, there's quite a bit more friction. It's not really a significant amount. I know that I've experienced this on previous Bear builds, but this one actually seems to be fine. So never mind. It does go in better the other way, but not by much. Are you guys, hey. Stop it. Okay. M3x18s. Let's go in here. I'm not imagining. Others that have built these, that tends to fit better one way than the other, right? Trapezoidal nuts on there. More M3x18s. Oops, wrong way. Trapezoidal nut. Tweezers here, and this guy up in there. I'm not going to, I vaguely remember that part opening being, no, me too. But this one actually fit just fine both ways. So, I don't know. I put it in, right now it's in the way that it fits slightly looser. We would have to check the CAD. It's a good point. That's in there. I'm not tightening these yet. These will get tightened once we're on the printer. We're just putting them in place. I still have my, I don't know if I've ever shown it on channel, but I still have my original, my first Mark III, my pre-order Mark III, ended up getting, I did a Bear frame install on it. I still have it, I just haven't used it. One more. Loose, loose. Okay. Then we probably have zoidal nuts on there. Do not over tighten the screws. I'm not tightening them at all yet. When do we put the screws in the end? Actually not showing them. These screws here. This should be, is that a later step? Yeah, they're not shown anywhere. We'll leave them off for now. Okay, let's put this on. Don't know what that was. Remaining rods on here. Objectively, is the bare frame that much of an improvement? Good question. Good question. Don't know. Careful not to fold over the seal in the bearing. Shouldn't push any bearings through the top. Move this down to about the middle, I think. Did you see that the bare frame, BearExxa are all... I did see that. What is OSHWA? What is that? I saw Greg's post on that. I don't know exactly what it means, though. And what do we have here? Open Source Hardware Association. Oh, okay. Oh, hardware, HW, okay. Oops. We're gonna put end caps on. So go like that, but we need, what do we have here? Don't. 1, 2, 3, and 4. And these are probably 10s, I hope. Yeah, 10s. I did see Greg post about that. What is involved in getting that certification? Go. Now that's interesting. Looking at that, everything is flush. The rod is all the way touching the stepper down here. It's all the way up here, and that's not flush with the top of the extrusion there. And I feel like it probably should be. get this. Yeah, I feel like that probably should be. It's not. Is it actually? Let's see. Make sure that it looks like it's flush, but we got to make sure. Hey, Daniel. Let's go. Let's get something a little more pointy. A little more pointy. Do some scraping around up in here. Because the reamer doesn't hit the very end. So I'm going to take my little round file here and just kind of clean up the end. See if that resolves it. They have a guide on their website on what all is required to become certified. Can't just claim. Oh yeah, I get that. Get the... Oh, that is better. Not quite there, so let's see if I can... Yeah, it does get tight towards the end, so that's probably what's going on. Let's see if I can... the colors just wow. Yeah, the LDO does a good job with their colors. This is an LDO frame. I don't know how long ago it's from. I know mine is black. My Bear frame is just black. I think I bought it in 2019. Might have been 2020, but I think 2019. I think that's what our core thing is here, is that linear rod bottoming out in the printed part. There we go. Yep, that's what it was. Now it's flush. Do the two ugga-duggas there. That's nicely. I don't know if we can get a good angle on it, but that looks pretty well centered, which is an indication that the stepper down here is mounted properly. If it lines up there, it's mounted properly down here. So now the other part is going through, and I don't know if I can get a view, but you can see a line down there. Don't worry about the debris. I need to blow that out. But you see that line down here. Here, that's what I'm catching on the rod, which I need to clean out. I hope that blowing this out isn't blowing any ears out. Okay. A Nighthawk stealth burner cable is starting to cause print failures. 3 prints in a row lost connection with the MCU. Interesting. Now, do you think it's the cable, or do you think it's a connector at the end, or could be something else? It worked. And that is... Hey, Birdman. Did I say hi earlier? Is it a Reve kit, and are you using it in a heated enclosure? Just getting this flush with the top, whatever that means. And that is nicely centered. So, Z-stepper mounts are good. If this was off in any direction, it would mean that we've got a the stepper mount itself is off. Woohoo! Nighthawk stealth burner, I'd suspect the cable. I guess it would depend on which generation. I think their newer cables are pretty nice. I don't know for sure on the older cables. Okay. Okay, now we're on to the extruder. So we are not going to be following these instructions for the extruder. Just jiggled it, MCU disconnect. So is that connector on the end? I see. That makes sense. How is it strain relieved? Who's that? Okay, so we are not going to be followed. This is the older extruder. Still uses the 40mm fan. So we are going to go back. Let's see, can we go back? Yeah, here we are. So we're going to go to Greg's main. And BearExxa V2 is what we're going to assemble. So let's see what this is going to take. For the current Bear version, we only provide a quick assembly guide. Oh, not print settings. Quick assembly guide. So this guide is only for the beta version. It's provided at your own risk. Read the project. Get the filament. Start by doing web browser, pre-flight check and disassembly. Well, we're just going to get into. So we're going to put in some square nuts. Go from here. I have a box of printed parts. So I think what my goal here is going to be to get as far into the mechanical assembly of the extruder here, and we'll save hopefully finishing this up for next month. Finishing it up will mean doing all the wiring, and the toolhead wiring is going to be a big part of that. Hopefully we can do it in one more stream. If it takes 2, then so be it. But what I do want to make some progress on this though. So put in a bunch of square nuts and hex nuts and lock nuts. Oh my. I don't know if it needs any lock nuts. I needed a third thing to complete the thing. I suspect, I felt that, I suspect that I've got some thick. So one of the things, if you've been working on Prusas for a long time, it used to be kind of difficult to get the square nuts that Prusa uses. And you can see here, it's a very small difference, but the commonly available square nuts are thicker than the ones that Prusa uses. If we go here, this is a regular one, 2.23 millimeters. This is one that Prusa supplies, 1.69 millimeters. So somewhere in this assembly, a more common, thicker square nut was sourced and installed, but I couldn't fit that into the printed part here, whereas that one goes right in. Cracked a few parts in the early days before realizing there were differences in those. Yep. Now I should say stainless square nuts were hard to find in this size. The little, you could get these zinc coated square nuts that would work. They're not great quality. You get these guys, these are thin enough, I think, to work. But the regular square nuts, these are the thick ones, which I'm gonna grab this one and just put it in my inventory there. Those, yeah. Okay, so we have square nuts there, and then we have 3 hex nuts on the back. What's up? Not enough strain relief. I tried to use a printed loop with cable ties to create some, but clearly not good enough. Yep. Something to be careful of that I've run into in the past. It's actually not great to use a stainless screw for this. You're better off grabbing a black oxide screw to pull these screws in. It is pretty easy to gall the stainless, basically lock the screw and the nut together when you're doing this stuff like this, where you're doing a lot of removal and reinstall. Okay. So, oh, interesting. Okay, so those are on, and then the 3S is gonna get a bits and pieces there. Did I print? Yeah, I printed this. It's this guy. Does this go, does that go just directly right there, or is there an intermediate piece? No, that goes directly right there. What do I want to do? Is there any... Oh, what am I doing? I clicked on that on accident, I see. So that all goes onto there, and then I've got a 3x10 and a carriage. Oh, you don't need that. So this is marked 2.5. So over here, got that. Then we're going to build on the extruder side. But what I do want to find is what Greg's recommendation is. We're going to go back over here and go back to what we were doing with the bare extruder and x-axis. This is a beta, like limited minimum required docs. It doesn't seem to have things like bearing orientations. Let's go through here and get it from the more complete docs. Manual, and here, and I think we can go here. So somewhere in here, I betcha, is specified how to orient the bearings. I'm putting this thing on, we just have to figure out where. Maybe it goes here. Here we are. Is there anything? Well, I guess there would be, but there isn't. Okay, well, I was wrong. If I remember right, the way that, maybe we go here. I remember correctly, the intended way to do this is if you have those, let's say that way, and you can see the marks there on the thing, you would orient the bottom one that way. So the this bearing down here is controlling this rotation, so the ball bearings in there being directly along that plane of rotation makes most sense. Am I right? Am I remembering right? If that goes there, these would go in an X up here. Okay, get this out of the way. Can I put this on right now? Is there any reason not to? Oh, and I do want to take this and just kind of knock down. We have mating surfaces here. Just want to take down any bits on the, any peaks. Does all like the top? There are some spots here that are intended to be raised, so you might want to make sure you don't knock those off. There. Okay. Get this on. That and like that. And I think these are 10 millimeters going in here. What? Oh, there we go. It's really tight on there. Why is that tight? Get the cat hair out of there. That is unreasonably tight on there. Just getting any possibility of print artifacts off of here. Probably do this. It's just on this the side here. Okay, let's try this again. I kind of messed it up a little bit there. And what about this side? That's correct. Why is that not to come on? There. No. Well, that is all the way. Why isn't that one? It's because that's not going in. It's in there. Ah, interesting. There we go. That's why. Sorry, I know I'm in the way. It's just a very tight fit in there. It fits, but it just has to kind of snap into place. Got it snap in once. There we go. There. Okay. Just a tight fit. For the furry orange supervisor. Thank you, Andrew. Appreciate that. Now that goes on there. Now that goes on there. There we go. I'm guessing some 10s just to hold this on. And I think, did I miss? I must have missed some. No, those are longer. Those are longer. Those aren't 10s. And the very black supervisor fun. Thanks, don't knock it. Okay, those other screws. Where were we? Here. Let's go back up here. These are in 3x18s. Yep. Those go through to the hex nuts that were in the front. Whoa, whoa, whoa. Okay, so what I'm feeling as that's going in is the screw here see if I can see it. The screw here is cross-threading in the nut in front. And I'm going to throw this one away. It's hard to tell, but I'm going to take the nut out as well. This pair is going to go away. Jeez. Really? Jeez. There we go. Those go away. So that is hex nuts. Fresh hex nut. And reinstall that. What I think is going on is I need to loosen these top screws, because with it loosened, it was forcing it to go in at an angle. So I need to, although I didn't tighten it, I tightened it more than it should be. Put this screw in just to get the hex nut pulled in. Pull it out. Okay. Go. But I could feel that cross-threading as I was putting it in. So don't want to deal with that. There we go. Top one. There. How thorough you are, it makes you feel normal. This should. We normalize taking our time on the build. Okay, so now this is going to go right on. If this guy goes on here yet, which piece is it? Is there a piece that actually goes down and holds that in place? Gotta be, yeah, that's gotta be this guy. This guy will go down here, but not yet, I think. I think that's a not yet part. This piece can go on though, and it's a 40mm screw. Excuse me. Yep. So this guy can go in here. I never put the square nut in there. There we go. Square nut goes in there. Okay. This. Thread on here. OCP. OCP, Rod. OCP. Okay. So that takes care of that. That is everything in here, except we haven't actually put the belts on. No reason not to. It's go ahead and belt it up. Now, one thing I want to go through that maybe the instructions are somewhere, but I don't know exactly where. If we look at this, there are these two screws that go into the end here, and they push against the rod. And what this is supposed to do is when you put the belt on, you're tensioning the belt between these 2 points. As you tighten that, it can pull. If the point where your rods bottom out in these printed parts, it'll pull until they're bottomed out. If that causes the distance between your bearings to be too short, then you're going to accelerate wear and potentially cause other problems on your Z. So what that is for is to make sure that when that is tensioned, that you're not pulling the whole thing inward. Does that make sense? So with the belt, you have lettering on here. So we're going to put it in such that we can read it. Standing in front of the printer, we'll go through here and around here, Adam. Let's do it like that. There we are. So this goes up. Do they still sell these frames? I do not know. The place that I bought it from is no longer in business. I don't know that LDO still sells them. I think we went over this last time. Anywhere you can find a bear frame is fine. Just because of the fully open source nature of the project. Greg isn't concerned. Okay, so this comes around. Come on, come on. There we go. Okay, so now we can kind of get an idea. Looks like right about where I had the other one is fine. Make sure we're, yeah. Work it in with the screwdriver. There we go. Slide in. Okay. And then we'll adjust tension here. Not 100% sure how I would want to measure whether that's that's putting too much tension on this or not. We could measure to the outside here and then down here and up here. And if it's bowed in, then we put it out, but that's not an easy measurement to make with normal tools. I think what would probably work pretty well is remove the lead screw nuts, remove them all the way to the top, and just move the axes up and down. I think that might be a way to do it. Let's get this to where tension is about right, and we want to do this evenly. So if we go or quarter turn there, we go a quarter turn there. That's probably on the edge of too tight. So I'm gonna go back that off just a little bit. I think it's probably kind of good right there. Yeah, that's probably pretty close to this. Yeah. We'll see how that turns out when we go, but we'll call that good. What happens if we remove these? Support this so it doesn't just drop. I want to try something. This to be in the center. Does this? Yeah. Still in. Must be that one. There we go. Okay, now let's move this all the way to the top. Now I want to take these, thread that in. It just threads into plastic. I can see the window here. See when I get it bottom out. So this will almost bottom out before it touches. There it is. Okay, so I'm gonna back that off. Dude, guys, what was that? Those were not happy noises. It's you, isn't it, Oscar? Did anybody catch that? What was the deal? Okay, so we're going to do the same thing here. Get this threaded into the same point. So feel this. There's no tension on there. Feels pretty good. May not need to do anything. go a quarter of a turn in. Objectively might be a little smoother, so it might be a good thing. I feel like that's slightly smoother than it was before. Only heard your reaction. Yeah, I don't know what's going on. Let's go just a tiny bit more. Siblings. Mm-hmm. It's smooth. It is moving the rods just a hair. I think it improved it. It's kind of hard to tell, but I know that it's smooth, so I'm going to leave it right there and just call it. Hi, Jose. Just the usual lick and fight routine. Except Felix got a little more perturbed. Okay, so now we can put this back up here. Line these up. Should go. Oh, that's why. There we go. This is not binding up. Let's get the long boy in here. I can get a straight shot at it. Tighten that up. Tighten that up. Okay. Now, the way the Prusa has solved this on the Mark IV is, if you remember during the assembly, there are some cross screws that you put into the printed part that give a positive metal stop to how far the rods can go in. That's assuming that you have tight control over the length of the rods and everything else. But when you're building a kit, you can, that's the assumption. Okay. Now we're on to, so the frame, the main part there is basically there. Now we've got extruder stuff to do. Let's see what this looks like. I'm going to open the door for them. Yep, Felix is over here at the door, being very patient. Them have their free roam now. Okay. So I get Oscar's chair. I get to borrow Oscar's chair. Okay. Now I'm going to go through here and just we're going to identify any areas that are supposed to be. Make sure we don't remove them. Although when we do this, we remove so little material. I'm just getting the little bits, the little peaks. did this one. Very little material. There's a little lip there that I don't want to disturb. That's fine. Cutter. This is the only other piece. Okay, I think that's it. So we have a whole bunch of bits and pieces to go in here. So we have a, let me get my box of square nuts. M3 nuts. So everybody ready for Murph? I'm ready. I'm not packed, but I'm ready. That's in there. Oh, that has some adjustment in how, oops, come on, into it. There we go. It goes into a slot. Okay, so square nut there, 2 hex nuts here. Oh, my 10 gifted memberships that I'm supposed to be able to give away once a month or during a month are, I opened a ticket with YouTube and took them a couple of days. I mean, I immediately got the, okay, we can't figure this out. Let's get back to you. I've gotten a few emails, couple, no, we don't know. We need more time, still working on it, that kind of stuff. But the latest email was basically acknowledging, yep, there's a problem. It might take a little bit to fix. Be patient. So, saying there's a problem. They're supposed to be working on it. So I'm going to try something because I heard that I may be able to use the regular viewer interface to do it, but I don't have much hope. I'll try it tomorrow though. But I did. I don't normally throw actual tickets out there, but this one I threw a help ticket out there and got something started. Okay, one more square nut over here. I'm just going off of this diagram here, just going through and setting all the things. So square nut there, hex nut, and then that's from that side. Now from the back side, square nut in here, interesting little slotted spot. Don't want to just willy-nilly put, like that looks like it would be a square nut, but I don't see anywhere that actually interfaces with it. So I'm not going to put one there. Hex nut here. Hey, bearded printer. Welcome. here. Pull this through. What was going on? There we go. Nope. Okay, so that's square nut, hex nuts, and square nut down here. Go. Okay. Whew. Now we have this piece. Let's see if we can bring this up. Here we go. A little better view. So the filament sensor adapter, and does this use the bearing I already have? It looks like it. So that guy goes in there. Oh, interesting. there's another square nut right there. So we've got this guy and a square nut down in there. Go. Another one of those that's slotted. And then this that has got to go that way. Just looking at how this works. That goes right there. Oop, and that falls out, so I'm gonna be careful about that. We need to put pieces in here. So that's gonna go there. Okay. All right, like that. Now we've got 10x6x2 magnet, and the other magnet goes here. So we've got this piece, and I've got my magnets here. I'm thinking these are probably them. There's a 20x6x3. Yep. So this is, oh, measure these things. So we're gonna have a magnet here, a magnet here. Make sure the magnet is pushing the lever against the steel ball. You can remove the magnet from the front in case of wrong orientation. The lever and 3x18 in here. Let this move freely. And then a cover that goes over all of this. So we've got a 10, yes, by 6, by 2. This is gonna go in here. Not pushing that. Oh, that's nice. That's nice. Everybody should do this. I'm a big fan. An access hole so you can push the magnet out later. So let's go ahead and just push it in. What is that? Here's something. That goes there, and then this goes this way. That goes in there like that. M3/18 goes here. And that looks like it threads into plastic maybe, just fine. Not worried about threading in plastic. Just going to go in until it touches and can still move freely. Still moving freely. Still moving freely. You can see it. You can see it blocking the filament path. So now what we'll do is we'll take this part out. It's the old part. Okay. Now we are going to, so if I put this way, it's attracting. If I put it this way, it's pushing away. So I put that right in there like that. And there is a access hole there to get the magnet out. Okay, I hear something going on. Give me one moment. Give me one moment. Okay, just something in the other room. Okay, so that's there, and now we have, where did I put that? I have a box with the filament sensor. It's this guy. At M2/8. Have it in here, or am I gonna have to find another one? One. Okay, so M2/8 and then an M3/18 to cover it up. So I think this is the correct filament sensor. Oh, it has an M2/8 inside in the thing. So that's there. That all works. Put this guy in here and sets right there. Now the question is, does this move okay? Yep. Moves just fine across that. Okay. Yeah. Okay. So 8mm. This is the 1.5. Right? Yep. And this is very much no ugga-duggas. It is a infrared sensor. The flag on this interrupts the beam in there, and that's what triggers it. It's not a switch, it's a IR sensor, optical. It's an optical end stop basically. And then there's wires coming to the back. Then all of this can still come out of here. There's the flag. then there's a cover. Let's be this guy. Now I can already tell I'm going to need to print a mod because I want to do a filament guide tube. This is intended just to have filament go straight in. I'll put some sort of ECAS or something fitting mod for it'll just replace this little piece here. It might tweak this one depending on how big the opening needs to be, but I'll go looking for a mod for that or make it myself. Now, this particular setup has caused, if you're not familiar with the with these, folks would print replacement parts in PETG. And even black PETG, if you shine a bright enough light behind black PETG, it'll be some color, often red. There might be an additional cap, Bob. We'll find out. I won't print something if I don't need to. But just because it's black filament doesn't mean that it will trigger that infrared sensor. Step files for those parts available? Absolutely. At the GitHub that we're at. That was part of the official Open Source Hardware Association certification, is to have all of the source files available. Not just step files, but actual source files, which is a whole other discussion, which we won't get into. Because I think there's the practical aspect and then the definition. So, okay, so that is that one. Let's go back. All right. Yep. So we did that. We did everything on here. And now we're going to get into, ooh, I need a bearing. Okay, that's fine. That's support. I think that's support for the other side of the extruder motor. So MR105ZZ. What is an MR105ZZ? Betcha I have one. We'll see. I'm checking my Amazon history. 105ZZ. Ooh, I have not purchased. What size is that? What is an MR105ZZ? It is 6 by 10 by 3. Just because I haven't bought it on Amazon doesn't mean I don't have it, though. 6 by 10 by 3? Why is it 3? Maybe I don't understand what this is for. Oh, no, that's a 106. Never mind. 105 is 10 millimeter OD, 5 millimeter ID, and 4 millimeters thick. Are we putting the Revo Micro in this, or do they use all the same part? I'll use the same parts. We are putting a Revo Micro in this. Oh, good point. Good point. This is a Revo. Is that an adapter? Is that an adapter? Is that what that is? Yes. Yes. So this is the little groove mount adapter for the threaded Revo Micro. Yeah. Let's see here. I have bearings, and that one is more than 4 millimeters thick, I think. Oh, it might not be. Let's see what we have here. My bearing organization is awful. Oh, 5 millimeters thick. It is, oh, it's 11. 11 by 5 by 5. That is not the bearing we are looking for. Not a flanged bearing. Oh, that's a 3mm bearing, so that's not going to be it. That's 5. What do we got here? 10 by 4 by 5. Woo! Got the bearing I need. A random bit of I wasn't expecting that. If I didn't see it on Amazon, I didn't have high hopes that I have it. This is V2 of the Bear Extruder. Uh-huh. Yep. Here we go. Okay, so don't press it in yet. Just let it fall down in the hole. Just don't press it in yet. Screw the E-bearing screw with a flat head screwdriver. Not seen it before. I built V1 and wasn't too happy with it. This is a whole different thing. You should check it out. I haven't tried it yet, so I can't tell you it's great. But it is definitely different as far as assembly than what I've done before. Okay, so we have that, which gets a bearing in here. Let's see how this works out. So we put a bearing in there, and those are threaded. So that, they just want us to drop it in there. Don't press it in. Ooh, my stomach is growling. It says don't press it in there, but I want to make sure it's going in straight at least. And then this guy presses it into place. Let's see how. There we go. Now, it says a screwdriver. Oh, darn. I was hoping that would be a... Let's see what I have. I got thumb pressure. I don't know how much it needs to screw in. I think that's how much. I don't think it screws in much more than that. There we go. Yeah, that's all the way. So there we go. And that, so this gives a positive end double shear support for the stepper. This goes in here. This is backwards. The gear on here goes the other way, but that'll go in there. Yeah, conic fab. Clear PETG cylinders with friction for idlers is a good way to organize those. Oh yeah. With friction fit lids, I see. Super late to the party. Hey Kilroy. Been moving all my printers into the new shop. Awesome. New shop's fun stuff. This feels so alien by comparison to anything I've seen elsewhere. Oop. Okay. Make sure that's all the way in. Yep. And 3 square nuts. That guy. That one. And this one. and 2, and a hex nut. Okay. So the Revo Micro here. Oh, let's put a nozzle on here. I don't care which one, just get something on here. Put probably a 0.4 on it later, but let's just get a nozzle on it. Go. And we pull this guy off. This off. And probably, nope, that's still on there. We need to do a 32mm PTFE tube, and that's what this little jig is for. What's that for? Okay. I think I have a piece in here. Oh no, why don't I have a piece in here? That's just wire. Okay, where's a piece of PTFE? Piece of PTFE. Where do I keep that? Two millimeter PTFE. Where? Oh, up here. I was looking for the little, all these Revos and such come with a little short piece. Gotta figure out where I ended up putting it. I'll just grab it out of, where's that? Right here. Just grab a piece out of here. PTFE tubing. Just got to make sure we grab 2mm ID, not. Piece. Not 2.5 or 3. Let's see how this does. Okay, so this goes in here. Nice square cut. Not displeased with that. And it is right at 32mm. But I'm going to take another little step here, grab one of my pieces, and just the chamfering tool. There it is. I'm just going to throw this in here just to support it. Throw that in there just to support it. Do a little, oh, geez. Okay. Just to support it. And do a little chamfer in the end. Yep. this thing out and throw this. Oops. Saw a piece of dirt there. I didn't want to get in there. Hold this down, this up, get our little piece in there. It's important to hold this down when you do that because you want this to lock up but not pull the PTFE out. Okay. And then this little adapter goes on here. Looks to be symmetric. So this guy goes on like that. Tightens down nice, and it is. I think that is, does that have little bridges? Yeah, that's not stringing, that's intentional bridges there to hold it together, but give it some ability to stretch a bit if it needs to. The Pinda probe. Super Pinda. And that goes in there. Align the Pinda to be at the same level as the nozzle tip and we'll adjust it later. Okay, so this goes here. This guy goes up in here like that. Takes that right to the end there. And then our Pinda probe, we're gonna get the old bend. So this was previously in a printer, so I still want that to go in the general direction. And there is a piece here, goes on this and holds it. So we're gonna, is that an M3x10? I'd like to see my year-long endeavor to build my 3D printing shop is finally done. Okay, we gotta pause and check this out. I'm all about the shops. I am all about checking out the shop. I'm gonna get this level. Just snug that for now. Let's look in stream chat. Stream chat. Is this like a separate building or an attic space or what? Moving printers and furniture today. Let's get an open in browser. There we are. That's what's the area? What's your floor area? Hey Liz, see you in a week. 200 square feet, nice. So it's effectively 10 by 20. Is it more like 12 by 16, something around there? That's one corner. This looks to be maybe the opposite corner. $14 by 14, okay. That'll be awesome. You have power going to it, I imagine, or I see. How much power do you have going to it? Okay, so that is that. So I'm just gonna put that off to the side, something like that. And then this is gonna go on here. And that is going to go with two M3 by 30s. Find my 30. Let's 25. These must be 30s. Yep. 60 amps, power, 5 circuits, 220 amp just for printers and tools. Awesome. I have 50 amps going to my shed, 10 by 12. I don't remember exactly. I think I picked that because of the gauge wire I ended up running. What size wire did you run there? Did you run 6 gauge wire, or what did you run for that? And how far is the run? Are you I can't tell from the picture. The picture's too blurry. Are you in the US? I can't tell from the outlets. Looking at the outlets, I can't tell. Okay, 6 gauge, it runs about 30 feet. Oh, okay. No, we don't get 400 volts to domestic residences. Okay. My run is a wire path is about right at 100 feet, maybe 90 or 100 feet. I opted for 50 amp on 6 gauge wire. Power nap packing starts today. What time do you get in? Do you get in Thursday or Friday, Liz? I get in Friday, mid-afternoon probably. Okay, so that is all of those, I think. Oh, shoot, no. Oh, hey. I did not pay attention, but it just fell into place. I didn't do that on purpose. Oh, the pinda wire is supposed to go through there. I didn't pay attention when I was putting it together. Cool. Okay, part 7. We get a nut into here, and then in 3x18. Little thumb knob into there. I have 50 amps, 120 amp circuit for the sprinklers, plus 30 amps, 250 volts. I have amplifier off of those. Yeah, I have a full 240 volts going to the shed. Currently, I have 2 20 amp circuits for outlets and 1 15 amp circuit for lights. Hi, Bryce. There we go. Make ourselves a little thumb screw there. Make sure it's fully tightened. And it is. Oh. Okay, here's where I want to do something. This build did not have it had a generic, probably 24 volt part cooling fan. I have, let me see if it's in where I hope it is. I have just an extra brand new Prusa 5 volt part cooling fan. So I'm just going to use that because it already has wire length and everything correct. At least I think I do. Oh, you know what? There's possible that it's not actually Prusa brand, but oh, it is. But why does it have a? Oh, did I do that? Did I do that? This guy, but I got shorter wires on it. I think I might have oh, I bet you this is when I was doing the switch wire development. I bet you I adapted that for for a different controller. Okay, so that's an option. That's an option. That's probably the option we're going to go with for the moment, because I'm fairly certain if I look hard enough, I can find a full length wire, even if it's one that was on a printer. I need to figure out some fan organization too. I mean, they're all in one box. That's something. That's something. So we're just going to put this on as a placeholder for all these parts, and I'll figure it out in between. So we need a couple of washers. Do I have more washers in here? I do. 2 washers. Several washers. Okay, 2 washers and 3x18s. Touche, Bob. Touche. I got electrocuted Friday by 400 volts from a lift. Ooh. Glad you're here, Tactical Printing. Glad you're here. Okay, so this and the fan. Little cool little fan duct. Okay, so this is gonna go. This goes here. This guy goes in here. So let's just get that kind of tightened. Okay, then this is going to go there like that. Now there's washer here, as there should be, because most of these 5015 fans are actually meant for an M4 screw going through there. And if you notice there, that one didn't have a washer before, and that's the indent from a socket head without a washer. See? Just the right size. So M4 is the proper fastener size for that, but a washer is better than not. Cool. We'll do something about that fan. Either make sure I extend the wires properly or find one with wires already on it. Okay, one Bondtech 3x32 shaft. And then the gear stuff. So this is all. Take this apart and make sure we have a reasonable amount of grease in there. So we're going to pull that off there. And then we're going to take this. And I think I had cleaned it out a bit before, but I'm just brushing it off with the brush here. Brushing any debris out of the teeth. Actually going to take this and grab some of the grease that was down in there to put on here. There we go. That'll be enough. There's already grease. We're just making sure that there is plenty. Okay, now this, and we're gonna snap this guy in here. There it is. You can kind of see where It goes in like this. Okay, and there is a square nut that goes down in there. Ella, are you still here? You made a comment earlier. This is a little different from what you're used to. What do you, can you pinpoint? Can you explain what about it is different? Is it the use of square nuts and captured nuts type stuff, or is it? I think anybody, because I've experienced it, anybody who wants a different perspective and a good reference to check for printability, designing for printability. I think Greg's stuff is a great example of that, and it's been that way for a very long time. There's a lot of lessons that I've learned going through the Bear designs and the Prusa designs too, going through a lot of this. Okay, that is to insert the gear on the printed part. Do not press on the gear, but on the extremity of the shaft as shown in the blue arrows. Yeah. That Bondtex shaft. Let me see if I have one of those. It's out of the way. I have a box here of Bondtex stuff in general. Do I have a 32 millimeter? This 32 millimeter 3x32 millimeter shaft. Is that this? Yes, it is. Woo! I'm getting all kinds of lucky today. Woohoo. Okay, so according to this now, this goes in here. It says that'll get pressed in all the way when we finish assembling this. So that goes there. And then we just did that. So now we're going to flip. Oh, we're actually using, okay. So this is, I see. It is not double shearing the stepper motor. I was incorrect. It's that bearing before is support for this. Okay. So I was incorrect. That does not go there. This comes off of here though. That comes off of there. And we need the Bondtech 17 tooth gear. So we'll just use a easy brass one. And this says a 1 millimeter space onto the bottom here. Right there is exactly 1 millimeter. I don't know. How can I tell? What do I have that I can put in there to space it off? Here we go. This is 1 millimeter thick. Oh, it's so close. So close. I mean, it would probably be fine. but it says 1 millimeter, so we're going to do, actually this measured at 1.06 millimeters, or yeah, so I think I got it exactly on. I think that's 0.06 millimeters of interference there. We'll just hold that on there. We'll make it 1.06. Tight. Make sure it's nice and debris free. Oh, I was involved with design and setup. Power is no joking matter. Here. So, oh, I need another one of those bearings. Did I put those? Is that one of them? I think it might be. Nope, that's 11. That's 11. I don't think it's in there. Which bearing box was it in? Here I am online. Haven't seen you in a while. How are you doing? Thanks for stopping by. By 4. Okay, so this is saying to take this piece here and a bearing spot right there, and the stepper now, oh, there we are. So it does say here to put the motor orientation, which is nice. I'll have to build up our Bondtech gear here, but I'll look through my stuff to find one. This goes here. That's a nice tight fit, and I think that's probably intentional. I'm doing fantastic. M3x6 button heads. Deviation from... is M3x6 in the Prusa catalog? Let me see. Maybe. What are these? Are these by 6? They are. Okay. They're in the Prusa catalog. We're safe. Okay, 2 and 3x6s. Right down here. Working on trying to figure out what the sequence and what the schedule of builds are. Did a little bit of thinking on that last night. I'm planning on a Micron rebuild. I talked to Heart K, and the expectation is that printed parts are all solid and ready. So I'm going to start printing parts for a Micron rebuild. There is likely a stealth burner build coming. That'll be based on LDO stuff, and it'll be my blue V2 we'll be doing that on. And I'm working on plans to redo my Tridex into a Mad Max 2-tool tool changer. And I'll be using the A4T tool heads on that. So I'm not sure which one we're going to start first. Depends on what I can get printed in the next couple of weeks. Because the next build stream, I'm hoping to stream from Murph next Sunday, but the following Sunday I'll be with Bill at Bar Z Bash. That's the 29th. On the 6th of July will be the next build stream. So, okay. Let me see what I have here. I got one of those. That'll do. That's all I need. Oh, is this a short one? No, that's perfect. I think that's all I need. Is this cut shorter on this side? Some of them are cut shorter depending on if I'm used them for a V0 or not. It's hard to tell. I got white, I got black. And I know I have others of these around, but not right here. So we will try that guy. And Bill is a bad influence. Bill and I will be at Murph with you. We can help or at least heckle. Bill won't be at Murph. Are you talking to a different Bill? Bill. So here's what we're going to do, Bob. We're going to have you in person at Murph, and we're going to have Bill relaying chat. We're going to reverse roles. Okay, this guy goes on here. Where? Oh, there it is. Do you have an opinion on the best tool head for a solid fork? I don't. I'm running Stealth Burner with the Revo Vitamins on my solid fork. Bryce will be at Murph. Awesome. I'll see you. See you there. But there's a lot of tool heads that have come out that I'd like to try. Like Ant Head is going to go on my Micron. It kind of has to. I'm open for suggestions on things I might not be aware of too, or have not given a ton of thought to. So if folks want to see something on one of these upcoming builds, so there's the Tridex going to Mad Max. I'm thinking that's where I'm going to get experience with building the A4T, which is the Zoll, same group that did the Zoll. And then Micron's going to get the Ant Heads. So Stealth Burner, I'm undecided on what tool heads are going. Stealth Burner, I'm undecided on what tool heads are going for that. This says small gap, 0.5 millimeter. $17 months. Thank you, Ram. Yeah, this is 0.4. This is 0.4 millimeters thick. And I have less than that on that. So I didn't even look to try to measure that. So we're going to go, just going to go with that. IDEX is a tough sell with Mad Max out there, unless you need copy mirror modes. And I have zero use for copy and mirror mode. So we may do some other fun stuff with the Tridex rebuild as well. I need to work out some things. Okay, so that goes on there. Bondtech 52 gear with drive gear. Make sure it rotates freely. The bearing in there. Connector orientation. And then this is going on the... Ah, I see. Okay, so that can go on there. Okay, so this is going to go and drop into that bearing. Okay. You're going to use CAN bus and Stealth Burner. I think Big Tree Tech made a major design flaw in that regard. SB. CAN bus and SB. What do you mean SB? Stealth, are you thinking stealth changer? And hi Kim, I don't know that I said hi earlier. Kilroy, thanks for being a member for 26 months. Thanks for the kind of words on the new shop. Kind of words or kind words? I kind of made words. Sometimes people understand them. I have quite a few stealth burners that are running on the CAN bus setup, Kim, as well as USB setups. Kind words. Hey, Marcus. Okay, so that's working well. I think we can prepare. Let's get this on there. At least so we get to the point where the extruder is on the machine, and that's where we will call it. See how far onto the machine we can get it. Here's this. Here's this. That is looking great. It's fine. That's the best part. M3x30s go through, I don't know what we're gonna do here. Maybe we'll do something like M3x30s. These two. We're gonna have two M3x30s coming through here. What it says. Okay. Place the extruder body on the X carriage. So this whole thing. Get these wires out of the way. Let's see. We can move this over, I think. I don't know what's, maybe this? Which two? Do those go through there? Maybe? Yeah. Yep. Okay. Those go there. Kim, you said, I think Big Tree Tech made a major design flaw in that regard. As far as using CAN bus or what? What do you mean? What do you mean by that? Cable routing makes it impossible to remove the front with ease. Only way is backtracking cable. Didn't like that solution, but maybe it's just me. Cable routing on Stealth Burner, as far as the toolhead board versus the fans and stuff. Oh, are you talking about the hot end? Are you talking about the heater wire that has to go back and then plug in from the back? I agree, it's terrible. I don't like it either. It's pain, but I only have to deal with it when I need to work on it. So I get the frustration though, because I've been frustrated too. I get it. Yep. I think when you're designing boards and you're trying to go so high density with the features and stuff, sometimes you allow yourself to compromise on areas, and that's a compromise they decided to make. But I agree. Yep. Okay, so that is bolted on there. And then we got the tensioner that can slide on. That'll go on there, and then the motor is going to go on. Oh, and that plate I'll use two M3x30s. So let me grab those. No, and then. What is that from? The quoting it's easier to quote than to remember what it's from. Dude, where's my car? Really? I think I might have seen that once. So I'm quoting that based on hearing the just the quote, not necessarily the movie. Okay, so we're gonna do basically this stuff here. We're going to save part 11 for next week or next month. I made a solution of my own, a split cable with 1.25 millimeter connector. Fiddly. Fiddly. That's a word I like to use to describe some of the things we do here. Let me get this here and here. Hey, you're both back. Yeah, I don't know that I've seen the whole movie either. Okay, so this guy goes on here. It goes in there, and we're just going to leave that loose. This wire we're going to here. And then this assembly, it's going to go on that dowel, has to go through that hole there. And then we have so there's no benefit to double supporting this shaft where we're interfacing with it and a low torque interface here at the base. So, okay, so and there's some index pieces that go in here. So I think this is going to go, should find the, get that out of the way. Probably, what am I running into? What is the first thing that needs to line up? Something that's not lining up. What's the first thing? Can't really tell. Is it this? Is it this? Oh, it's gotta be. Oh boy. Oh yeah, that stepper's not gonna work. This stepper's not gonna work. I think I can show this. I gotta figure out what to do about the stepper. We might be able to do that right away. But go here and you put this in here. I guess you can't really see it from there. But what you do see is that the Bondtech gear is not the one that's stopping us. It's this major stick out here that's hitting right in the back there. So let's see what we got. So how can we fix that? Aside from cutting the gear, which might be the solution. Let's see what the, yeah, and you look here. Look how short that is in the picture. That is not what I have. I like that, Bill. I heard M8 bolts referred to as tiny. Yeah, relatively they are. I want to go all the way up here and go to the bomb. Is there a bomb in here? No, let's go back here. Bill of materials. Let's look here. The x-axis, the extruder. Pancake motor. LDO, I wonder if that 20, that's probably referring to as the body length. Doesn't actually say anything about shaft length. I have no real problem with cutting this stepper down. Give me one moment. I am going to go check my larger inventory of steppers that's in the other garage. I very likely have what I need here, but if I don't, I can cut it down. But I'll be right back. Okay, I'm back. Don't actually. Well, I do. Many of these would probably work. That's what we need. Hold on, I'm not quite done. Okay. Another thing of steppers over here. Uncover. Let's see, is that it? Yeah. Okay, here's what we got. Here's what we got. Anyone have experience with the Nighthawk SB cable saver? Not sure what that is. Got a few pancake steppers. got a few. So this is the one that, this is a 0.9 degree. So right off the bat, probably want to run a 1.8 degree, right? What does the Prusa is going to expect a 1.8 degree. So we probably didn't want to run this one to begin with. So then I have, I think, two more of this same stepper. Same too long of shaft length. Two more of that. And then I have a bunch of generic steppers that I don't really want to run, but they probably have the correct shaft length. All of these are all the same. I don't know what I got them for. Oh, that's a Winson. I don't know what I got those for. And then I have these two, which are, I don't know, but I'm pretty sure I used these for the Z-axis on my CR10 back in the day. I got another generic. What I think I might use is a Voron afterburner stepper. It's got a short shaft. It's an even lighter stepper. I know it's going to have enough torque for this because it's a 50 to 17 ratio. I don't know the total count of steppers I have. It's ridiculous. It's quite ridiculous. It's like the fans. I just have piles of them and I don't know how to organize them. Okay, I'm gonna put these away. I think we're gonna use the afterburner. The generics do look like Creality motors, but their OSM is the thing. But I don't think I'm not sure that any of the Crealities use this short of a stepper. I don't think I have 100. I don't think so. If you added them all up on the on printers, probably, but I don't think I have 100. I think that's crazy talk. I think I'm going to use this afterburner stepper because it's got a shorter, probably correct. It's going to be lighter, so we could potentially get better performance out of it. So let's do that. Let's pull this out. Have to count the ones in use. Yeah, then it could be. I mean, you figure I have 30 something printers and each one of those have minimum of three steppers. I mean, really 4. You're right. You're right. It has to have a minimum of 4 steppers. Okay, so challenge will be in the wiring, but we'll figure that out. 1.8 degree generic steppers came with a Bondtech extruder upgrade for the Prusa. And I have that. I have that Bondtech extruder upgrade on my Bear Prusa. Okay, this was, where did we go? Did I go away from the instructions? I did. Quick assembly guide. Okay, down and like this, right? Yeah. When does one admit they have a problem? I have no problem. I don't know what you're talking about. I don't know what you're talking about. But I think the type of stepper is probably a good thing to check out. The 0.9 degree stepper probably wouldn't have been a great idea. We'll put a big old Voron logo on the front of this printer, front and center. That's the thing to do, right? Yes, Leo. Their birthday was 2 days ago. We are introducing them to catnip tomorrow on stream. First time. I didn't want to take that off. I didn't want to put that on yet because I need to put the gear on. Thanks. We have some treat I noticed that we've never given them that has catnip in it, and that's the idea tomorrow, is see what they think. Hi, Karma. Welcome in. We're not too far from done here. That's on there. This tighter fit on this stepper than the other one, but that's okay. This will go in here. Come on. Go in there. You were in there before. There we are. There we go. Now we can get back to putting it on printer. There we go. Okay. So, way. I'll just get in the way. I'll just get in the way of the shot. This is an effect, right? The filter. It's the beard filter. So now this piece is the challenge. There we go. Ha! Perfect. Does that motor have the correct gear on it? The correct gear? What do you mean? What do you mean correct gear? Yeah, I put the same brass 17 tooth on there. And looking in the side here, you can see there's the Bondtech gear. 2 and 3x30. These guys go through here, and from the back. Oh, I'm in the Voron ecosystem here. We've got two M3x50s to put in. Do I have M3x50 stainless? Maybe. I have one. Maybe two. No, what size is this? Been known to use a 10 tooth on a shaft instead of a 9 tooth. Happens when you start digging around the motors. Well, this uses the Bondtech gear. There is a 17 tooth. That's only a 40. I only have one stainless 50 millimeter screw. I will bet you I can find another one, but I'll just grab a black oxide one. The whole thing jams up at 180 degrees. Oh yeah. Yeah, it should be. I can see the, oops, let's go here. There's two that come right back here, and these go all the way through and thread into the steppers. So these are the last two screws to get the stepper secured. There we go. There we go. We still have, oops, not that one, this one. We still have the tensioner to put in. But that looks pretty darn good. Let me get some wiring out of the way here. Oop. Yeah, I like it with that shorter stepper too. That's 5 millimeters closer, less 5 millimeters less stick out, less weight. Doesn't have the lower mount on there, but that looks great. Okay, so that does that. We've got the idler here. If I look down, if I sight down that, everything should line up well. Yeah, it does. The gear lines up right with the filament path. That drives in there. Yeah, that looks really good. So what we have here next is the tensioners on there. Those two M3x50s are there. Make sure the extruder body is aligned with the carriage. We don't have this bearing covered yet because we do that after cables are in. We're gonna run all this stuff through the end. We got the fan that goes on. It doesn't say what screws, but we'll figure that out. Oh, none yet. Never mind. It doesn't use screws. It uses a cover that holds it, that pinches it on. Two, three M3x10s, and then all that, and then we have we'll double check this with a piece of filament to make sure everything is lined up well. What we are missing that I didn't catch is it's probably the same setup that came off of here for filament tensioning. But did I miss it somewhere? Or the idler tensioner. Let me see. Did I miss putting that in? I think it might be missing, but let's see if this works. So this is the one that came out. This is a 40. It should just go through here. Yeah, I think so. I think that's all it does. We'll have to pull this off next time, but there we go. And I'm guessing same thing, head flush with the side here. Just this guy right here. So that in there. Set the filament tension, and then if we pull all this stuff, let's get that way. And then this fan, this is the fan that came with the Revo Micro. I think we just squeeze this and fan pulls out. So, let's see, is there a recommendation on wire? Okay, fan cable goes up to the corner here. So this drops into there. This comes through here and through there like that. And then get this piece. Gives plenty of wire lengths because these wires will come through here. I'll go up out of the way there. Right, like that. Two. I'm not going to tighten that down because I am not convinced that I don't have, well, I guess I do. I guess I am. There's nothing, if that moves, it's not pinched. Yeah, not pinched if that moves, so. That goes like that. And that's it, that's all the part cooling fan. That matches, goes there. That's right there. No, this looks great. I'm pleased. And that's really good progress, considering we went from bare frame, We went from bare frame to not bare frame, bare frame. Awesome. So there is going to be quite a bit of custom wiring on this in terms of wire lengths, and we've got to figure out how to do the connection for the stepper here. We need to figure out extending the wires for the fan. Most of the wires should be the correct length just by virtue of being off of a Mark III. And then we'll use the adapters within the electronics bay for that. The power supply ends up going over here somewhere like that. We'll put that on next time too, I think. But this is good. I'm very pleased. I'm very pleased. If I was doing this again and I had thought about it, I might have done a little more black parts, just because the frame already being blue kind of, it feels like these blue printed parts don't go as well as I think they could. I probably would have done anything that doesn't bolt to the frame in blue, like the gantry pieces, but these might have ended up being black. If anything floated, then it would be blue. Anything that bolts actually to the frame would be black. If I was doing it again, I might have made an exception on the idlers just to mix up this, do black on these and blue idler and stepper mount or something. But I do have the black channel covers. Yep. Those are in there right now. But awesome. With that, what are we at? A little over 5 hours for a member stream. I appreciate very much everybody who has stuck around. How many people do we have here at the 5-hour mark? We still have almost 60 people here. We do have 60 people here and 58 likes. So someone asked why you beat up your printer. It's all black and blue. So with that, thank you again. Thanks for being members. We are back on the Core 1 build tomorrow. I expect to finish it, and I expect to be printing and then playing around with ClickMate crimping. So for those that aren't going to make it tomorrow, that are fathers or happy Father's Day. If I don't see you tomorrow. Otherwise, have a good rest of your day. Enjoy the build, everyone. Bye.